because you're in the wrong place. All right, everybody knows what they're here for. I very much appreciate y'all, making it out to see, what Covenant is all about and giving me your very valuable time. Yeah, with that, I guess we'll just kind of get right into it. To start, I figured what's going to make the most sense is to just go with a little bit of like demo time, because that's going to help contextualize everything. That it's like, this isn't just some like theoretical bullshit. It's something you can actually run and use, and we'll revisit that later in the afternoon. But for now, like, you can look at like, pretty software. So what we have here is the Sapio Studio. And the Sapio Studio, a little bit finicky here, let me scale it, is a Bitcoin wallet that is kind of like smart contract aware. So you can do normal stuff with it like you would do with any wallet. You can go and you can get a new address, you can send funds around, you can see your previous spends, but you can also play around with Bitcoin smart contracts. And so to start off, I'm going to show 2 smart contracts. There are like many, many, many more, and the kind of sky is the limit with what you can do in this model. But we're going to show 2, and those 2 are going to be maybe inspiring to help you think about like, well, what are other things that you could do in this way? And we can then get into the weeds later this afternoon on like, well, what's actually going on behind the scenes. But for the morning, I figured we just like show, and I'm doing too much telling anyways. So let's get into the showing part. So I have this this wallet, and I have like nothing going on, but I want to make a smart contract. So what I'm going to do first is I'm going to go to contract, and I'm going to load some WASM plugins. I've got a bunch that I built here before, and I'm just going to say I want all of them. I'm going to click open. Now in the background, these are getting processed and loaded up. So I'm going to give those a second to go. And then I'm going to go ahead and click contract, and I'm going to click create new contract. Now, what that's going to do is that is going to load up a list of different contracts that I wrote. And there's a lot of different applications that are here. Some of them work well, some of them don't. I'm going to focus on ones that work well right now. But you can see that these are all kind of like little applets. So you could imagine in the future, like somebody sends you one of these, or you download one from the internet off of, with Web of Trust signatures from developers you like, and then you'd get some new functionality into this wallet. These are all kind of plugins, if you will. And so the one that I want to show you first is a vault. Who here likes vaults? All right, everybody likes vaults, so it's a popular one. The second one, I think less people will like, or at least they'll not admit to liking. So we're going to start with James Vault. So this one is really important because there's this really handsome guy up here who wrote the initial version of this, and then it was adapted to Sapio with a couple extra bells and whistles. But essentially, what you're seeing here is a form, and the UX library I'm using for generating these forms had a bug, so I had to revert it to make it like ugly. But when they fix that bug, or when I upstream a fix to it, it will be beautiful once again and look like modern, material UI stuff for all the designers in the crowd. And so in here, we basically have to like fill out some information about the vault that we want to have made. And I have some data that I'm going to copy from over here that is useful for this. So I have down here just some keys. This is, you probably can't see it that well. Let me make it bigger. I have some extended pub keys that I'm just going to copy. This is key 1. And so I'm going to say, OK, well, backup direct. If available, this key can be used immediately as a single sig cold multi-sig option, usable with musig key. So I'm going to paste in that key there. Backup address. This is where funds should land when they're backed up. So I'm going to go to my Bitcoin node, and I'm going to get a new address to my clipboard, and I'm going to paste that guy in there. And then I've got this CPFP anchor thing. I'm going to use the same address for that. You could use a different one if you wanted to, but I happen to have one on my clipboard right now. And I'm going to set an amount of funds for CPFP. This is sort of a technical detail of like getting transactions to confirm in Bitcoin. So it's important that we have that for correctness, but it just needs a little bit of Bitcoin so that you can use it to bump your fees later. Then I'm going to set a fee rate for this. I'm going to set something kind of aggressively to 10,000 Satoshis per virtual kiloweight unit fee rate. If that means nothing to you, it also means nothing to me. It's just like some arbitrary unit Bitcoin uses, and 10,000 means about like 10 Satoshis per byte of data, which is, I don't know, maybe aggressive, maybe not aggressive, depending on what things are looking like. But we have the CPFP outputs for if we get that wrong. So the next, I'm going to copy another key. This is key number 2 I'm copying, and I'm going to paste that in. This is the hot spending key which can be used to spend from the vault, timeout after claim is initiated. So I'm going to paste that one in. And now this is one that like I can actually use a little bit of audience help. Who has a favorite number? Does anybody have a number that they like? 22? 222. Okay. So we're going to put 222. Right? I got that right? Okay. So this is a relative height, and it's going to be after 222 blocks that the hot spending path will become available in this case. So we're probably not going to see that happen today. This is on Signet. So now the amount of funds. Does anybody have another favorite number that they would like to put for the amount of Bitcoin going in? I've got up to 10,000-ish Bitcoin on this node, but if I use it all, then there'll be no demos later today. 20. That's a big number. Come on, you're trying to run me out of town here. I'm just going to do like 2 Bitcoin. Because I want to be able to run these demos without having to reload this node. 2.1? Okay, there we go. 2.1. All right, now this you can ignore. This is kind of something that is relevant maybe later. And then we're going to create it for Signet. So I'm going to go down here and click Signet. Then I'm going to submit that. Boom, we have a smart contract that gets made. And what you're looking at is a couple different things. These rounded rectangles up here, these represent like UTXOs, and these are unknown ones. Like Sapio doesn't really know what's going on. We could ask the chain maybe like, hey, do you know about these? But Sapio doesn't really know. But then there's internal ones like this one that has our little bit less than 2.1 Bitcoin. Some of it got used for fees. That was kind of our budget for this contract, and some of it got consumed. But we got about 2.1 Bitcoin in this vault, and then the square rectangles with rough edges, pointy edges, those represent transactions in our smart contract. So that's sort of a little bit of the visual language. It's also color coded, and there is dark and light mode. So you'll get some optionality there for the light mode fans. I know there's a lot of you. So what you're seeing with the purple lines represent options. So from this output, you could have this transaction or this transaction. And then the blue lines represent different outputs that get made from a single transaction. So one way to think of it is purple is exclusive OR, and blue is just kind of like either and or depending on how you want to think of things. It's like all of the above. And so now that we've kind of gone over just like basics of like what you have to understand to like look at this graph, let's talk about what's actually going on here. What we have is a funding transaction that creates the contract and creates some change. And then we have a output that represents our contract up here. And then it has different state transitions it can undergo. We can back it up to cold storage, which creates a basically 2.1 Bitcoin output with a CPFP thing so that we can drive it through if we need to bump it in the mempool. And then we also have something where we can begin redeeming this output and then moving it into our hot wallet. And then once we've done that, we have a way of generating a emergency backup where like somebody's trying to claim the money and we didn't authorize it, so we really now need to move fast. We've got 222 blocks to do so. And then there's this updatable thing which lets us do this hot spend path. So I'll go ahead and do that now, just so that you can see kind of the full flow here. So I'm going to go to my Bitcoin node. I'm going to get a new address to my clipboard again. I'm going to click updatable, and then I'm going to click spend hot. And now it prompts me to put in information for the hot spend that I want to have. So I'm going to name this thief. And then the address to pay to is the one that I just did. And how much Bitcoin? Well, we've got like, let's say like 2.098, because we've got 2.099. So we're going to use some of it for gas or fees. So now I'm going to click submit. Nothing's going to happen because it's basically queuing up all of the different state transitions I want. But once I've queued up all the different things I want, I click recompile. And then what it does is it regenerates the contract with the state transition that I requested. So you can see now this transaction has showed up that wasn't there before, which is this spend via hot. Maybe I can make this a little bit bigger at this point, which is the spend via hot path. And now we've got like a new transaction. So does everybody see the state transition that just happened? Is anybody like lost completely? Is anybody afraid to admit that they're lost completely? Okay, one person, all right. So we're doing all right. We've got now this spend via hot, but like we still don't really have a great sense of like when can happen. So, or when different things can happen. So we're gonna go ahead and click simulate. This is gonna bring up our timing simulator, and we're gonna drag this in, and what we're gonna be able to observe is that this hot spend thing, if this is like some like fixed starting point, let's say block 339 relatively, that we really have to go like 222 blocks before this transaction is able to be broadcast. And we see that visually as time goes by. This thing becomes either possible or not possible. And so we know how much time we have. And it's about, I don't know, like a day and a half or something like that. Yes?
I guess with this showing, since everything's unconfirmed, you just created a potential theft path, but it's not that the theft has occurred yet, right?
Correct, yeah. This is a potential theft path. And it's also not even a theft path. It's like, this could be you legitimately trying to claim your funds. And we'll talk about how this might integrate with like other services later. But that's just like, if you want to use the hot spending path. This one we called thief just to be, like cute. Maybe it's somebody compromised your vault setup and they're now trying to like steal your money. But yeah, this is still a potential vault, but should we go ahead and create it so it's like no longer just a potential contract? Because that's one thing that's fun about Sapio is like you can really simulate and play around before you've ever sent any money into the thing. But let's go ahead and send money into the thing. So now we're going to click on this root transaction here, and this is our funding transaction, and we're going to send it to our signer, and we're going to get it signed. We have to click it twice because of some weird PSBT flow details. But now it's fully signed, and now we're going to send it to our node, and it's going to relay. And then we see it show up that it's now in our mempool. And so this means that like the node is aware and has tried to relay this to other nodes, and at some point this will confirm. We can wait around for that, but it should take about 10 minutes or so, or so probably not immediately. But now what we can do is we can kind of do whatever we want. So there's all these other transactions too. This one's also updatable. If we click on this, we can see the state transitions we're allowed to do is just a spend cold. So there's sort of like this idea in this vault of like, you always want to give people as much flexibility to use their emergency backup procedure. This is kind of the high level goal of this vault, but we can talk more about vault designs later. But for this one in particular, like you have this goal of like, you have your hot spend thing, which is like a single sig key that like lives on your phone, and you begin the withdrawal process, but your emergency services have the ability to like perceive that this process has begun for like a whole day and a half. And in that whole day and a half, you have like a myriad of different ways of trying to get your emergency keys to be triggered. And what you can do is you can do two different things. One, if you have access to your emergency keys, you can generate a new spend that you want. So if I click this spend cold thing, I'm able to specify like, hey, here's where I want the funds to be sent. And so send them this way. But I'm also able to just say like, I don't have access to my emergency keys. I can't take control of the funds immediately, but I can send them to these emergency backup keys. And this is kind of a nuanced point because normally when you set up like a multi-sig, whatever your backup is, you have to be able to get access to it. And this ends up being an issue because what you have people doing is you tell them, hey, the best thing you can do for your security is like have one key in every state, or like have a key all the way across town. And then people go, well, that's kind of inconvenient. What if I do a multi-sig and I've got one key in my pocket and one in my desk drawer. Is that good enough? It's like, well, maybe not. And ultimately, I think everybody here knows what a lot of people end up doing is just doing single sig all the time because it's like the most convenient. So what this does is this gives you a hybrid model where you can say, look, one time you're going to go and set up these emergency keys, and they're going to be kind of inconvenient to get to. Maybe like when you're going home for Thanksgiving, you like leave a key at your folks' house buried in the backyard, and you're like, I can get to it if I have to. I can tell them, where to dig, but like, I'm not going to be able to get it normally. And then you set up a path where you say, well, if I can wait for just a week, or in this case, 222 blocks, then I can get access through like my mobile phone. And the funds are never sitting on your mobile phone until you've actually claimed that you want them. So it's this kind of nice hybrid security model where your emergency procedure is very clearly an emergency procedure, and your normal access condition is clearly like a normal access condition, and you have time to choose between them if you get compromised. So this is still sitting, but what we'll do now, just to kind of show you that this stuff works, is I'll click down here, and then I should be able to, so now I can relay this transaction as well. This will take a second to show up in the mempool. Now it's in the mempool, and we'll leave this sitting, and we can revisit it in a little bit. But when these get mined, this will show that all the other possibilities are now no longer possible, and that the funds are sitting in our cold storage key, waiting for our emergency recovery to begin.
So is the idea here, like, if that transaction created originally was theft attempt, you would have already set up, you could either sign a new transaction to give access to keys, send it to a predefined wallet, or send it wherever you want, or you can pick like a backup path that you would previously set. Is that what you were just kind of going over?
Let's see if I can do this. Yeah. I think the question was just kind of like, what's actually going on here? So I think maybe like if I'm fast with my fingers right now, I can probably just like show you what I mean by this. So this like begin redeem, this is when somebody is like trying to get access to the funds. And imagine you're running a service that's like, hey, if somebody begins redeeming, but I haven't sent you like a top P code, like please have the watchtower do something, right? That could be kind of a thing you could imagine. And so we're gonna show something that's like a little bit similar to that. So now what we see down here is like, okay, well, let's sign this one and then send it to the network. And now this one is on the network. And I think I set it up correctly, for the demo, that this one has priority over the other one. So now like, oh no, this is in the mempool. Somebody's trying to get this confirmed. What should we do? And what you can have the service doing is, remember that you have all this time. You've got 222 blocks before this one comes into play, but this one is available immediately. And so your watchtower service can just go ahead and say, okay, well, we're gonna send that out to the network. And now that's in the mempool. And then when that confirms, that's gonna block this other one. And that one can't go in the mempool yet because it's like a hot spend path. So that's kind of the model where like you have these flows that can like take the funds back. And if you're not happy with like this one, for example, because you're like, oh, I'm losing too much money, in fees or something, like you also can generate the spend up here. And I'm not sure what mempool settings I have right now, but like, yeah, this one you can see like now I can't broadcast this one, and the error is insufficient fee rejecting replacement, because it's trying to replace this one, and this one's offering more fee than this one is. So that one now is kind of blocked out of the mempool, but I had another path to be able to, to be able to get the thing through. That's the secure backup option. Does that answer your question?
Yeah, I guess a little bit deeper would be like, so the idea that you would set up like a few predefined like backup wallets that you could always send to, like you're saying, various keys in your backyard, or you could sign a brand new transaction that would override the other one, or like once. Yeah, I guess this takes a little bit of setup on the front end, right? To have these backup addresses.
Yes. So I think what you would, you saw what the setup process is. It's literally just using Sapio Studio to be like, send money to this place. Some of that can be like automated if you had like a service that like understood Sapio contracts and was like, by all means, we will deposit directly into your, vault. Because you could imagine you withdraw from an exchange, and they, instead of giving you the funds on a single sig, they like will, and you can actually do this like opaquely to the exchange, so they don't know what you're doing. But if they send you the wrong amount, there's kind of a problem. So it'll probably take a while for the cultural norm to evolve that like when you request a 1 Bitcoin output, they cannot give it to you in 100 million pieces. This is, that's, I think I popularly used a metaphor during like one of the Atlanta, bit devs things of like, it's kind of like one of those money guns, where it like sprays money in the club or whatever. And if somebody's like, hey, I owe you $10,000, and then they took out a money gun and just started spraying it in the middle of the street, like that's not a valid payment. Like you can take them to court and be like, you didn't pay me, it all blew away. And it's kind of the same thing if somebody sent you like, if you are owed a Bitcoin and they sent you a Bitcoin and all dust outputs, also wouldn't really be a valid payment. So it's one of these things where like, we already know these things to be true, that when you request a 1 Bitcoin payment, that it has to be literally exactly 1 Bitcoin. But there's sort of like this weird, like people are like, it seems fine, where they're like, they send you a little bit less because they're like, oh, we accounted for fees. And that should never happen. Like when you're dealing with like a payments rails, like everybody in finance knows you never use like floating point numbers because you want to have the exact precision on like where your payments end up. Otherwise it's an insufficient payment. So that's something I think that like some exchanges are bad about today. But all that said, you can imagine the case where it's like you request a withdrawal from your exchange and it just automatically shows up into one of these. There's no like additional setup, and the exchange can even like set it up for you completely, and you can verify it later on your own. So you don't even need to like, if they're automating this for you, you don't need to like trust them. You can just, regenerate it and check that they did it correctly for you later. Does that kind of make sense? Like the setup is not like, oh, I've got to go do this big ceremony. The ceremony part is I set up keys one time once, and I never have to access those keys again unless there's an emergency, which is a huge departure from today, which is like anytime I want to get access to my funds, I have to do my emergency procedure, which is not like, if you got to do it every time you want access to funds, it's not an emergency. So this creates a new class of like emergency backup path, which is, I think, a really big deal. Are we getting more? These are great questions, by the way. If anybody else has questions like that, keep them coming. Yeah, in theory, I mean, like, I think the like end result would be if an attacker has your key, you would end up like fighting in the mempool and it's burning all your funds or something like that. There's also probably like some universes where like there's miners who say, look, if you send the funds to us, we'll like try to get it back to you, because if we can tell it's kind of clearly a hack, like, we'll try to do the right thing for you. I don't know if that's gonna ever happen, but like there's maybe some stuff around like what the different flows would be. And we'll talk about that later, because there's a section about like how you make value-added services around some of this stuff. And some of these things, it's like, well, if you go through like 10 iterations of like trying to get your funds, like maybe you just send it to somebody who has more competency in getting funds recovered, and then they will give it back to you. But they're not, that's sort of like the new case of this emergency path. Like they don't ever have access during the day-to-day, flow of your funds to anything, nor if you're just sort of like offline for a while. Like there has to be some commissive action on chain for you to be able to initiate this hot spend path. Cool. Are we good on vault questions? Because we're gonna do like a lot more. This is just to like be inspiring and like show you what's being built, and then we're gonna talk about a little bit lower level, and then we'll go way lower level in the afternoon. Does anybody else want to see anything about these vaults? It's not confirming just because. Oh, this one confirmed. So you can see this one is now no longer in the mempool, but these guys are still sitting in the mempool, so it'll be a little while. In theory, like I don't have it wired up right now, but like these you could spend from. These outputs will show up in like the Bitcoin Core wallet, and you could be like spend from this, and then that would allow you to bump the priority of this in the mempool. This is just Signet though, so like the mempool is empty. It's just like however long it takes for it to get included in the block template. And I'll be able to bounce back to this one later and show when this confirms. All right. If we are good there, I will move on. Last call. All right, cool. So the other demo I want to show you is an NFT. Who likes NFTs? Okay, like 2 people. Come see me after. I'll give you an NFT. Maybe. So who here likes discrete log contracts? Okay. Who here likes like things like on-chain loans? Okay. Who here? What's another fun? You have any other fun ones? I'm blanking right now. Yeah, who likes options contracts? Kind of similar to DLCs, but a little bit different. All right. So who here likes any of the last three things I said, but didn't raise their hand for NFTs? Okay, there was more of you than that. So I know who you are. You lost one honesty point today. Just kidding. All of those things are NFTs. Like if I have a discrete log contract and then somebody else is like, hey, what do you have there? Can I be like, oh yeah, you should totally get this thing. It's these like mystery oracles that you've never heard of before. No, that thing's not fungible, right? It's a non-fungible thing, and what's in it, well, there's some amount of value that's locked up in it. So that thing is an NFT. Same with a loan, same with an option contract. All these things are like not strictly fungible, but you could trade it, right? And you can trade NFTs too. It doesn't, like, fungibility just means that like each instance of the thing that might have the same economics is not, you know, the same exact thing. And so what's important about that is that NFTs exist as just like an abstract way of thinking about digital objects of some sort. And when I say NFTs, you're all probably thinking of like pictures of cats that are like drawn to look like cartoons by a third grader. And you're like, I don't like that, right? But that's just like one application of it. Really, the more important part is that NFTs can represent things in an abstract interface. And all these things that we care about, like discrete log contracts and options and loans and stuff, you could think about all of those as an NFT. And then if you built out really cool tools for NFTs, you could probably use those same tools for this myriad of other things. So that said, let's look at an NFT. Let's like check it out. So I'm going to go to contract. I'm going to go to create new contract. We get to see James again. And then I'm going to go down to simple NFT. What isn't an NFT? Good question. And then this is kind of annoying to fill out, so I'm going to cheat for a second. Let's see if I can set that down for a microsecond. Okay. I'm just going to copy some data that I had from before somewhere. Right. So what I'm doing here is like I've just like done this a million times, so I have all the data that I would enter by hand, and we'll talk about each field, but I don't need to like copy paste everything. And this is useful if you're ever using this software as well. So now I'm going to paste this in. So what do we have here? What is going into this NFT? Well, we've got, you know, this is an art NFT because it's the simplest kind to think about. We've got the artist public key. We've got some signature from them over some piece of data. We have a content ID that we're going to get through IPFS. We have some edition information. This is a one-of-one NFT, very rare. There's no legacy web page because we're all about the web now. We have an NFT version for extensibility. Right now, you know, we just set this to 0 because we only have one kind of NFTs. We have some key that's going to own this NFT. And then we have a royalty. So that's like some amount of money that's going to be paid to the artist anytime this NFT gets transferred. And then we're going to lock up a Bitcoin in this NFT because it's like ultra valuable and rare, and we're going to imbue it with some real hard assets that you could take out if the art ends up being worthless. And then last but not least, we're making it for Signet. I'm going to click submit. Oh, if you just saw that, the other transaction's confirmed. So we can revisit that in a moment. So now we've got an NFT. Ain't she pretty? Anyways, so you can click here, and then it pulls up metadata for this NFT. It loads it out of IPFS. This is showcasing a really cool part of how Sapio works, which is that it can export structured metadata using something called the Sapio Interactive Metadata Protocols, or SIMPs for short. And if you use the SIMPs, you can basically build interactive features in higher order software that can either ingest a Sapio contract and then hook into each of the transactions and like do certain things. So this is still under development, but you can imagine things like this transaction should automatically be broadcasted if I observe all of its parents being able, you know, to be spent from. So if all the parents are in the mempool, then please try broadcasting this transaction. And you could build out automation flows. For example, you could say, if you observe this transaction in the mempool and you do not have a top P code in your database for the user confirming that they wanted this transaction to be there, then fire this other transaction. These are all things that you could build as this sort of hooks layer that's metadata lifted out of the Sapio contract. So if you're kind of wondering, like, are these just things that I have to play with in a GUI only? These are things that not only can you build interactive experiences by defining standard types of metadata that can handle it, but you can also hook this into various bits of infrastructure if you're building out a service around this stuff, which is pretty cool. But what is an NFT, that's just a piece of art good for? Selling it, right? Like that's the only thing you can do with these things. So we're gonna go ahead and sell this NFT because we don't want it anymore. And so we're gonna go to make sale. We're gonna name it buy. We're gonna name that the sale. We don't have any extra information. I don't really know what we'd put there for this one, but we're gonna price it in sats. We're gonna sell this one for, it's got a Bitcoin in it, so it's worth something, but we're gonna sell it for only 10,000 sats. The sale should be possible. This is just a Unix timestamp of some kind, so I'm just putting in a random time. It's like, I don't know, that's like ancient, so that's like 1970 or something. And then the key that will own this NFT, I'm gonna go ahead and copy. We're gonna sell it back to the artist. They really regret selling us this NFT earlier. So we're gonna sell it back to the artist. And then here's a really cool thing. Which sale contract should I use? Now, you would think that the NFT might have to know inherently how it's sold, but who here knows how NFTs are represented in Ethereum? All right, so this is a really big topic, which is that in Ethereum, who here has played with Ethereum at all? Okay, so if you haven't, recommend just testing what's out there in the market for your own learning experience, because if you're trying to build stuff, there's a lot of things that are cutting edge and they've fucked up enough that you can learn from where they messed up and you can probably do something better. So one of the things that they really have right is interfaces and abstractions on those interfaces. So ERC20 tokens, it's just an interface, and anything can say, I'm represented as an ERC20 token. NFTs are represented as ERC721s. And this idea that I told you about earlier of what if your discrete log contract is just an NFT? Well, in Ethereum, Uniswap v3 represents all of its positions when you are trading with it as NFTs. And what that means is these positions that you have, you're able to use any of the existing infrastructure for a generic trading of things that can be described as an NFT to trade your positions. That's a very powerful idea because you can basically, if you built an in-game item system, you can hook that into the NFT infrastructure. If you build DLCs, you can hook that into the NFT infrastructure. And so the NFT infrastructure ends up being a unified marketplace interface for exotic semi-fungible goods. And that's a pretty big idea. So what we're gonna do is we're just gonna pick a sale contract now. I gave you a lot of text, but I'm gonna go ahead and I'm gonna say, okay, we need a hex encoded hash of a WASM module that knows how to sell an NFT. And the cool idea here is that there could be many different things that implement this interface. It's not just one that I'm handpicking right now, even though it literally is just one that I'm handpicking right now. But somebody else, even after I already made this NFT, could come up with a new one, and I could automatically be able to use this new one. That's a really big idea. So to get that, I'm going to go here, and this is one of these things that I'm working on making the UX even better. But right now, you gotta bear with. This is alpha software, and I'm going to list out all the contracts I have access to and what their hashes are. And I'm going to see simple NFT is down here. Now, it turns out in the back end, these all implement something that's automatically type checkable. It's just I haven't wired that up to work in the web forms that it would show you here as the options that we're aware of. Right now, you just kind of have to, by hand do this, which is unfortunate. But if you like working on UX, very tricky problems, I would welcome your help. So we're going to now paste that in. And we're using the same update mechanism as before. So we're going to click, did I actually copy the right one? Let me check that. Oh, I copied the wrong one. I need simple NFT sale. That was my bad. If I did submit this, the compiler would catch it and it would say this is not an NFT sale contract, but I want to show you the demo working. So now I'm going to paste that in. That's the correct one. I'm going to click submit, and then I'm going to recompile, and then I'm going to close this out. And now what you can see is this is a sale of the NFT. And I had to do a couple hacks to get this working properly, for getting things end to end, sensible, but this is something that I'm going to tidy up with some modifications to Sapio to make it support things like this natively a bit better. But the logic here is actually still correct. And what you're looking at is down here. So we have our NFT still, and we have the metadata here. But what we also have is a transaction that is taking in some funds from an external input. And if this transaction is authorized by us, and we'd have to like sign it, this is an area where the simps can help us, because the simps can say, when we've generated a sale contract for the price that we've agreed to sell it at, please automatically prompt the user to sign this transaction. So it's not something you have to think about. It would just be like, do you want to sell the NFT at this price? Would be the prompt that you would get. These are things that, in the works, but you can imagine how it might work, maybe. And then, so we have the output that then, and this is what will get truncated eventually, because this really just only needs to be one transaction. But now we have the output that has the sale price in it. And then we have another input coming in, which is not strictly necessary, but that's the hack on top of the hack to make this demo work for you today. And then now what we have down here is really neat. We have the NFT again, right? This is the same thing, and there's a traceable chain. Who here likes Taro, like the coin asset protocol? Works exactly the same kind of way. What you're doing, and it's similar, it's a little bit different, but what you're doing is from here, you can trace backwards and you can see that this was done through a valid series of sale transfers up to the original. And along the way, you have a rule that's enforced, and the rule that's enforced in order for this NFT to be valid is the royalty has to be paid. And so we see here the sale price gets paid, which is 10,000 sats, but there's a 10% royalty that goes to the artist. And so you might be thinking like, dude, bro, this is like so fucking stupid. Nobody cares about any of this art bullshit. And that's a lot of what I get whenever I try and tell people about NFTs. But here's why all of that is wrong. This is a DLC. This is a market maker. This is the market maker getting some sort of right for matching the order. Like, these are things you can start thinking of that are like actually pretty cool, that you can enforce, and you can have all the logic for building out like a smart contract marketplace that's happening, that's being driven by, sort of, I call this peer-to-peer FI, for example, where it's not quite like the Uniswap experience where it's just like a single automatic market maker, but you can build out all the logic for how these things should interoperate and have a huge amount of automation going on of what is the thing that we're even trying to agree on. And you can write this all in like a very small amount of Rust code, which is what's really beautiful about this. So does anybody have questions?
Could you just highlight where the covenant part of this is? Like where's the covenant that's like enabling this?
Yeah, that's a great question. We're gonna get a lot more into that later in the afternoon of like, what is a covenant? What I'd give you right now is that, who here has like bought real estate ever? You lucky folks, I'm a non-homeowner. I live in a cardboard box apparently. So if you've bought real estate, who here has like seen covenants in their real estate transactions, right? Okay, or like in a legal transaction, you've seen covenants, right? Are those covenants? Like, because covenants, I thought it's like this weird thing that Bitcoiners talk about. Well, actually covenants are like a legal concept. It's a concept of like any sort of restriction on the transaction that's above and beyond like what the transaction really should have in it by default, right? And so people have had issues with covenants in the past, like in California, there used to be a lot of like racist covenants in like property transfers that were like, you're not allowed to sell this house to a black person. And like somebody who's totally not racist would like buy the house, and then they'd go to like try and sell it. And then somebody in the homeowners association of that neighborhood would be like, well, actually you signed this covenant when you bought the deed to this house, and you actually can't sell it to that person. We don't want that neighbor. And this took like a very big kind of like constitutional amendment in, I think in the California, legislature to basically get rid of all those covenants, all those restrictions. But the reason why I mention this is that those restrictions were not enforced by the blockchain. The blockchain didn't exist. Those were enforced by courts and by people. And so when I say covenant, all that I mean is a restriction that is enforced in a contract somehow. And the somehow could either be, in the case of check template verify, which is what you conceivably, a bit of why you're here is to hear about that, could be enforced by the blockchain with that. Or it could be a group of multi-sig signers who have instructions on things that are well-formatted transactions for them to sign. And so you could have a covenant that's enforced by, say, a federation. And that is what's happening here, is actually the covenant in this case has zero consensus meaning. Where it does exist is in the signers know that they have to follow the transactions that Sapio is outputting, if they want somebody else in the future to client side be able to validate that the NFT was well formed in the future. Because if you fail to pay the correct amount of royalty as computed by running the Sapio contract, somebody will go, buddy, like you did not pay the artist, so this NFT is now burned, has zero value. Now, maybe there'll be a market for like rip-off NFTs where somebody says like, oh, well, like, you know, this is still the same chain from the UTXO, but we have changed some detail of it, but maybe that's bullshit. And maybe people won't want to value that because it doesn't respect what clearly the covenant was supposed to be. And you can do things in Sapio when you're trying to make these contracts that give you a little bit more teeth into that. An example would be having sort of like Taro, like some committed piece of state. Like what if you commit to the Sapio contract code inside the contract itself? Then somebody can't show you like, oh, here's something else, run it with this other client. You'd be like, well, the root commitment of that is the code I'm supposed to be running. And if I run that code, I can't reach the state that you're showing me. Therefore, that's not the NFT that you're trying to sell me. So this is a very powerful idea, but none of that covenant for this contract in particular is happening using check template verify. And that's a very, very, very big idea, and probably something we could talk about, you know, for a whole 2-day session. But I don't know if that answers your question of like, where's the covenant here? From a, you know, covenants proposals for upgrades perspective, there is none. From a like, what is a covenant really perspective? Like it's kind of just like the signer, single sig signer has to follow the rule, or they end up burning the asset because nobody can validate it was correctly sent from anymore. And that's how Taro will end up working, is these things will be done by the person who owns it.
In the absence of CTV, does Sapio actually do that commitment of the rules of the transaction, like with a hash into in the multi-sig case?
Yeah. So in this one in particular, I have this type of NFT, and there's actually like, this one will be really fun in the technical workshop because you'll see how many layers of like interfaces there are, and like where you can change things out. But in the implementation of the NFT interface, which the simple NFT implements, it commits to the details of what the actual art metadata is, so that it's actually, you can't change the art metadata. It doesn't commit currently, although I could change it to, it doesn't commit to the actual WASM code that has to run. But you could just have it commit to that as well. There's a way of getting a self-reference into the WASM module that's currently executing, so that you can commit to that as well if you wanted to.
And curious, was that just kind of, you know, time trade-off thing, or was that like an explicit reason you didn't do that?
So one reason not to do that would be if you ever wanted to upgrade this NFT. So one thing you could do is you could say the artist has to like you have to have a signature of a WASM module by that artist, and you could basically you could have a database that you build in the state transition system of where you could do something that like injects a new signature, and you could commit to that, you know, data over time, so you could see what was the, you know, what were the previous state transitions adding in, and then you'd be able to revalidate by building out that database again. So the answer around that is like you can have some of this dynamism, but if you want to upgrade the contract later, maybe the artist wants to decrease their royalty, or maybe they want to you know, permit some new feature that got invented. If you're committed to just explicitly that WASM module, you might be a little bit stuck. The sort of master stroke would be for somebody to like come up with a thing that allows a state transition to a new WebAssembly module, which you can do the same way that I passed it into that contract. And you could say, now run it under this other one, and maybe this other one is somehow compatible, like backwards compatible soft fork of the old functionality. That stuff kind of makes my head hurt a little bit, but like it would take a lot of development in the like user land of like just how you use the tool already as it's defined. It wouldn't, in theory, in practice probably it will. It wouldn't require new features in the Sapio language itself. But in practice probably it would, because there's like, it's a sophisticated feature, and it might not be too ergonomic to do things like that.
So what is the execution environment for Sapio contracts? Like in Ethereum, the Solidity contracts run on the EVM. And what are limitations, if any, on these Sapio contracts? What cannot do?
Yeah, that's a good one. So usually when people talk about Bitcoin smart contracts, and you know, I think some of this we have some of this stuff in the slides too. So you know, we'll get there, but repetition is, you know, good. for learning. So people talk about like Bitcoin script, and they're like, Bitcoin has smart contracts, we have script. And it's kind of not really what people are talking about when they say smart contracts. I mean like things that like have some like statefulness to them. And what I try and push out is that the Bitcoin virtual machine is really the stuff happening at the transaction layer. And you should think about scripts as just sort of like complex instruction set opcodes. An entire script is just a single opcode, which is like a predicate of did this thing get authorized for this specific transaction. And really, the really fun and important logic happens as a VM that is the language, in the formal computer science context of the word language, of transactions that can be expressed in Bitcoin. And it's a little bit of a different way to think about what is a VM. But if you think about like a database, it's like, yeah, it's kind of like a language over a database.
So does it, so the Sapio contract essentially translates into a series of opcodes that get executed?
No, so if I can actually pull it up if it's at all interesting. Actually, I wonder if I can do this easily. I don't know if this feature still works correctly, but we can try. So if I click this, this isn't really the thing that you need to save anymore. I've like automated this, but I still have this view. This is all that's getting sent over to the Sapio client, along with maybe some other stuff. But it's just a list of PSBTs at the end of the day. Is what Sapio Studio is seeing. It's this list of PSBTs, metadata over all the outputs, and the metadata includes, things like it's not showing all the stuff. So let me pull it up in over here. So I'm going to go ahead and put my microphone down for 1 second. Okay, so I'm going to show a couple things. First, I'm going to show you the args that go into it. I don't even know which contract this is, so this might be a futile exercise in a second here. But here's like some arguments that are getting passed in. This is arguments for a different contract I haven't shown you yet. And so it's not the best example because I ideally would have picked one, but I didn't know which one was which. But like these are the arguments that get passed in to create a contract. And then this is what Sapio outputs as sort of like a raw like contract data that can be bound to any UTXO. So you can claim a UTXO like is bound to this contract, and it's like a lot of metadata around like addresses and options for spending and descriptors and stuff like that. And then when it gets sent to Sapio Studio for visualization, it's this bound representation over here, which has a couple different things. It's mostly just a list of PSBTs, a list of the different types of metadata, and then there's also a, maybe I don't have one here. Yeah, there's a table of things called continue APIs, and the continue APIs are the things that tell you like how to generate new state transitions to pass back into Sapio to do that as a loop. And so Sapio is code that's running, that's generating the state transitions for you, running locally on your computer or running on a federation's computers severally. And you would everybody run the same thing basically in lockstep, and it's WASM, so it's deterministic. And then that would generate what the transitions should be. And then Bitcoin is only validating the transactions themselves and validating the opcodes at any given step, if that makes sense. It's kind of a very, we're going to get way into this later, but you asked the question. So if that's like good enough for now, then we'll keep going. All right, cool. All right, any other, do you know if there are people in the video who want to ask questions? Okay. Alrighty then. Anyone else?
So I'm just trying to think concretely of like to be able to state the answer to that question myself, and maybe in the context as well of like what both Unchained and NIDIG provide as services. If we think about like the like a common flow that Unchained will do for, say, a loan, where you have your collateral in this loan contract, which is just multi-sig, and then there's a path that would be, under certain conditions, such as the price of Bitcoin gets up to a certain price, now you're over collateralized, there is a path where you would redeem, and even in Unchained's UI, we have you set a static redemption address, such that when you want to redeem, you just say, okay, redeem to this address. And so the Sapio execution context is basically that path where it goes from the collateral contract to this redemption address, and you're kind of like locking in or presetting what those transactions look like, right? Because what those transactions will look like. It's just you're waiting for the right conditions under which to spend them.
Yeah, and I guess like from the perspective of like an Unchained engineer, what you would probably end up having is you would have like a team of engineers who are working on the custody modules and defining a well-defined interface for that is pretty stable, let's say, but they might be innovating underneath the hood on that. And then you'd have a loan products engineering team who would be making a interface that accepts the interface for a custody module for a loan contract. And then you would have a separate team that would be sort of your DevOps team who is designing simps that are going to be a part of the contract that would then hook into the system as an integration layer and would say, here's the metadata we need passed out of these contracts for triggering the actions that you want. And then you would still probably have like another team that would be like actually auditing the composition of those things in making sure that you're not doing something like wild when they all come together. But you would have different components of the stack that would have clean abstraction boundaries between them, and Sapio would do the magic of like hooking everything together, and then your DevOps engineers, maybe that's like the wrong term, but like your integration engineers would be managing the like, are our systems able to like automate the state transitions for these appropriately, and like are we monitoring like our watchtower services, for example, and those all of those could be piecemeal. Like you could have a watchtower that's just triggering like margin calls, for example, and they would just be handling only the margin call simp type thing.
What's nice about that too is then you just remove a certain element of trust, because this is pre-computed, as you're pre-committed to, especially as well, which is that's the contract, is that pre-commitment to this path.
And that's a line between like the types of covenants and how Sapio thinks of it, is that like when you go to sign things, like what you're authorizing out of Sapio is until there's like more sophisticated covenants that exist. Right now there's only multisig and CTV. Sapio, you could integrate any other covenant, but you always end up with a list of exact transactions pretty much that would end up on the network. And so you can do a lot of static analysis over those graphs, and you can have like entire services that are just like, is this a sane graph? Or are we noticing any invariants that are incorrect? And then we shouldn't sign anything if we notice any invariant seems to be off in this. Whereas for a more open-ended and I talk about this sometimes in terms of like cardinality, like how many options are there? For a larger cardinality type of covenant system, you might just like not know that you've excluded all the bad things. Whereas this is like the
Turing complete versus non-Turing complete type of argument.
Well, it's different. Sapio actually is Turing complete because it can run for an infinite amount of time. So that's actually, but you can't send to it because it won't give you an address if it's running for an infinite amount of time. So that's kind of one of these weird things. But if it generates a program, then you have all the reachable states as a part of it. Whereas like even like simple covenant proposals like tap, leaf, update, verify, like it has an infinite set of state transitions, and so you can't show what all those state transitions are that are currently being proposed as a part of sending to a taproot address. Whereas in Sapio, like currently with the covenants that are in it, like you could tell what all the state transitions that would be asked to be signed and do a static analysis over that. And those things can't happen without sort of you opting into it, which is a nice property. But there are other reasons why you might prefer something else. But I think for a security conscious organization, the like less things happen that you're not expecting is probably a decent property. But certainly like the more like research oriented things, like maybe you could just make something that's completely automatic and very safe, and maybe that would be better. So I don't have a super strong push on either side of that. I just think this happens to be like workable. Like I know how I could build a service around this. Are there other questions on this? How are we doing on time? That's the question I have.
An hour and 20 minutes for the...
Okay, cool. Shall we get into some more boring stuff? All right.
Yeah.
All right, so now let's look at some slides, because you just saw a lot of stuff. Is anybody like overwhelmed at this point already? Okay, a little bit. I apologize. This will hopefully kind of like revisit some of these things. Like I did that because I wanted this to be like exciting, like rather than just like a bunch of boring text. And then it's like, what are we even talking about? Like now you know at least what we're talking about, right? You can see that there's like this ecosystem of stuff, but now we can you talk about like what is this whole like project of covenants that we're doing and why is it relevant and good and stuff like that. So if you've got the slides, I've like tried to have everything like very linked up in here. And so that's all available and you can check things out on your own time. Schedule, I didn't really know how long things would take, so whatever. What I want to talk about first is the pillars of Bitcoin. And I call these pillars, but I actually think that these aren't really pillars. I think they're more like arches. Does anybody know like the physics of how arches work? Okay. So if you don't know, because some of you don't know, is that arches are like kind of very unstable, right? Like a pillar, if you took off the top bit of the pillar, it would still be a pillar, right? It would still kind of work. An arch, if you took out the top stone of the arch, it would completely fall over. And it's not until you have some sort of like keystone that locks it in that it's stable. But then when you look in sort of like the history of man's architecture, like arches are actually like very, very lindy. Like once an arch is up, they can stay up for like a very incredibly long amount of time. It's a very stable structure. And so when I think about these properties of Bitcoin, scalability, self-custody, decentralization, and privacy, what I think about is one, are these kind of like this like minimal set of like really important things for Bitcoin? Are there other properties too? There might be. For me, I think that these are kind of like elemental, axiomatic things that like Bitcoin has to have. And you can talk about related properties of like, well, do we really care about decentralization? Are we actually talking about censorship resistance? And maybe there's a little bit of wiggle room there, but I think of these as like 4 separate properties that are kind of unrelated from one another that may have some synergies, but like you can't get much simpler than these things. And if we don't have any one of these things, I would say Bitcoin is fucked and worthless. Like that's sort of my view of how the network works. Does anybody like have any other ideas of like things that they think are really important that aren't covered by these concepts that they just want to throw out? Scarcity. So that's a good one. I would argue that goes into self-custody. And the argument for scarcity as versus self-custody is that if somebody can make more of the thing that you have, then you don't really have the thing, right? So your self-custody, like maybe there's like, maybe the scarcity and like property rights can be bundled into like a tighter term, but that's sort of like this thing of like, do I have the thing that I have? Or is it not as strong of a guarantee of my ownership over this system as I might like to have? Does that make sense as like a reasonable model of why that's kind of bundled there? Fair enough. We don't have to agree on this. I'm just trying to make a framework that we can at least have the discussion. Are there other? Okay, so we've got scarcity as like something we should think about as well, and we'll keep that in mind.
Maybe another way to name it that includes both of these store value, right?
Sure. Yeah. Maybe store value is this more elemental way of talking about it. So I think if to revise this framework, I mean these are blog posts, so like I can't change the title of them now, but like if I could change it, it'd be like maybe scalability, store of value, censorship resistance, and like privacy would be. But then is privacy censorship resistance? Like I think it's kind of a different thing, but. In any case, the core idea is that these are important properties. If Bitcoin does anybody think that like Bitcoin would be okay without one of these properties? That's kind of another interesting question. Like, would you still value your Bitcoin the same if like you felt that one of these things were like severely eroded? Who here would like sell all their Bitcoin if they knew like one of these things wasn't going to hold?
Privacy already isn't really holdings.
Yeah, that's a good one. Do you believe that we can fix it?
I hope.
Yeah, okay.
I believe that there's hope.
So let's get into sort of like, with the framework in mind, basically, that we're trying to think about covenants as like a keystone technology to lock in these, I should really call them like arches, but pillars is how people traditionally think of it. Let's talk about like why these things are important, and then we'll talk about like how covenants relates back to that. So for scalability, like if Bitcoin only served like your, I guess now I can't really use this one because I guess it's politically sensitive, but like your like, Russian oligarch, like mega yacht people, and like that was like all Bitcoin was good for, like I wouldn't really care that much about it, right? Like I don't care that much, like mega yachts are actually like the coolest thing in like self-sovereign technology. You can have an entire floating city, right? Like that's a really cool idea, but like that's not going to help most of humanity. Like it's a nice idea, and maybe like one day we'll all like be like on our own spaceships and stuff like that, and space cowboy stuff. But like we're not there right now, and Bitcoin is something that like is targeted at something every person is able to benefit from. And if we're not scalable, then that's not going to pan out. And if you think about what an autocrat can accomplish, like it doesn't matter if you have one mega yacht that you're on by yourself, if somebody like coerces hundreds of millions of people under brutal military dictatorship and forces them to do bad things, right? Like that's sort of what we're up against as a species. Like can freedom be the dominant paradigm for humanity? And maybe Bitcoin is a vaccine that's not mandated but open for anybody to choose, that helps protect us against these types of outcomes. And everybody's got to be able to use it. Like, I mean, that's something that I think there's a lot of discussion that happens where it's like, oh, well, not everybody's going to have a UTXO, or not everybody's going to be able to use the system. I think that's sort of rationalization for us not knowing how to scale things better. Where I think if you sort of gave somebody the choice of like two black boxes, and one could support all of humanity and one could only support like 10%, you'd obviously pick the all of humanity one. Like if you disagree with that, like, I'd be interested to hear the reasoning for it. But anything that's like, that's like, oh, well, like that's all rationalization to me. Like we should keep our eye on the prize. And if we have to compromise on our way there, so be it. But we should never shift our goalposts because of the limitations of the technology. We should always know what we're trying to do. Does anybody want to jump in? Like, this is interactive. So, if you disagree, you can tell me why I'm an idiot. All right.
I guess that kind of goes to the scarcity thing as well, right? Like the point why scarcity would be important is because like when you have inflation, that tends to benefit the yacht owners, right? Because there's only a certain number of people that can control the inflation rate and who gets access to that new money. Whereas if we have the scarcity limit, like that's also part of that eye on the prize, which is why Bitcoiners rightfully like value it so much.
Yeah, I think there's a lot of fertile ground for discussion on the relationship between like scarcity and scalability, where like one of the things I personally worry about is that like I don't quite like the idea that somebody born today has just like dramatically less ability to earn Bitcoin than I had. Like I look at certain things that were like generational benefits in like, California's like Prop 13, if people are familiar. It's like this like wacky property tax law that's like very, very nice for people who like were, around in the 70s. And like you have, people who are paying like 100 times more property tax, like that are next door neighbors. And like, I'm like, I don't know if that's like a good foundation for society in certain ways. So like I worry about that for Bitcoin, of like can people earn enough relative to what, others maybe, have as an intergenerational, wealth thing. But I know a lot of Bitcoiners feel strongly that like inflation is the much bigger risk to that, because you have the cantillionaires, earning, things, sort of skimming off the top. And I think that's something that will probably have very big, like people worry about the block size. Like that's going to be like a real big debate in the future, especially with like the block subsidies going down. So we'll see how that pans out. But I'm with you on like that there's a relationship between like how many people can use the system and how liquid are sats overall. Like that's an interesting point. Anybody else want to jump in with anything? All right, cool. So the next one is self-custody. Who here knows about Executive Order 6102? Okay, a few people. Basically, what happened is in like what was it, 1933 or something, 1930, the government said, you now like can't legally own more than like a jewelry amount of gold, and you certainly can't use it to transact anymore. And this was something that actually like, you know, was kind of weird because like normally people are allowed to own whatever they want as long as it's not like incredibly like, you know, dangerous to everybody around you. Like, I don't think, you know, people are allowed to own like, you know, I don't know, like massive explosives or something like that unless they have like the proper licenses, and that's kind of like a public health interest thing. But generally, like you can own whatever you want as long as it doesn't like inherently have some risk to it for other people. And what the government saw in this Executive Order 6102 is they were like, there's a risk to society of these people holding this scarce asset and not putting it into the economy. And we need to get these greedy people who are holding all this gold to not do that anymore. And so they kind of illegalize gold. And you would think that this would have like a really big impact, but they didn't do that much with it. What they did is they gave people a haircut. They said you got a little bit less than you have, but they did round people up and throw them in jail and, you know, punish them if they held their gold. Foreign nations who were like, oh, we've got gold reserves, can you give them back? They were like, it's like now American property, and, you know, you have a note with us, but we're not going to give you your gold anymore. And so there's a lot of like weird stuff that happened, but it wasn't until I think there was like 1 or 2 haircuts that happened, and somebody can correct my, you know, my history lesson here. But and then in you know 1970, like the 1971, like the gold standard like formally like ended, and the dollar was no longer like redeemable for an amount of gold. And then things, you know, there's like people really, you know, look at this date, and you know, then things really just went nuts. I mean, from my perspective, like overall, like would I rather live today or in 1971? Like I'm gonna pick today. So like, you know, obviously like it wasn't like the worst thing that happened, but there's a lot of like weird social impact things that you're like, well, look at this metric. This thing is now like weird. Look at like obesity. This is now weird, and the trends, you know, point back to this time. But like there's also billions more people alive today. So, you know, who knows the whole set of things that go into this. But there's a lot of people who are like, look, the only reason why this was able to happen in the first place, and this is the really central part, is that the number of people who actually had their own gold was small. And so when the government went and said, can we actually make a measure like Executive Order 6102 effective, they were only able to do that because a very large share of the gold was already held in reserve at banks. That's the really important part of this. And so when we think about self-custody, as an important property, what we're really talking about is if there were to be a world where most Bitcoin was held on exchanges that are regulated entities, it would be very easy to have the government pass a measure that would then cripple the ability of Bitcoin to be used in everyday commerce. And most people would now no longer have access to this thing. And you might say, well, it doesn't matter. I'm a self-sovereign individual. I've got Bitcoin. But it doesn't matter if you're the only person who has Bitcoin. Like if you're the only person running a Bitcoin node and you don't tell anyone, like that's not really a network. And if everybody else is like, well, I had Bitcoin, but it was too hard for me to hold, and then it got stolen, and it's still hard for me to hold, there's not a resurgence that happens. So it's sort of one of these properties where in order for Bitcoin to maintain its status, we need to have like very, very, very high penetration of people self-custodying or having, you know, their coins in a manner such that they can always guarantee their availability of them without a third party intervening in that ability. And this doesn't mean that like exchanges are like bad or that they should like go away and like anything that's like not fully self-custodial is bad. It's just like, it would probably be good if things that are not self-custodied were like somehow limited to like 10% or something like that. Or if people who are serving in an exchange provider type system didn't need to have full custody over the funds. And these are things that we can think about, you know, too, in terms of covenants of like, what about covenants where the emergency procedure backup like sends funds back to customers and maybe sends funds back to a tribunal of customers who try to reallocate. Maybe there are things that we can do that make it so that even in the case of some sort of enforcement action, the people who are custodying those funds, like their hands are like somewhat tied to actually do the thing. And, you know, structurally they cannot honor whatever the order is that is sort of a surprise order that feels unconstitutional. So that's sort of, you know, when we talk about self-custody, it's sort of like this pledge together strong kind of thing. Like, unless we're all doing this activity, the fundamental value proposition of Bitcoin is significantly diminished. Does anybody have any questions about that, or like disagrees strongly? Is like, nah, Bitcoin's fine if we're all, using what's the least favorite custodian that people have? Coinbase. Okay, well, I'm on video, so hi, Brian. So yeah, sure. Like if it's all on Coinbase, we're kind of screwed. Does anybody like think that would be a fine outcome? All right, so we got to be self-custodied. Okay. The next pillar is decentralization. This is kind of, as I said earlier, a proxy for censorship resistance. Censorship resistance being that like when you decide to take an action, nobody can stop you from doing that, and nobody interferes. There are a lot of like nitty-gritty details that go into that, and like there's a lot of problematic technologies in my view. Like I love Lightning, but like it has like some problems around like, well, like what if somebody blocks you? Like, do they have an incentive to steal? And does the fact that a miner could have an incentive to steal that doesn't work when it's decentralized, does that lead to a competitive advantage when you are centralized? Because now there's an incentive to become more centralized so that you can steal. And then what's the amount of decentralization that you need to prevent, for things like Lightning, people from stealing, so that people are like selfishly interested in always mining transactions as soon as they're available? There are all these like very thorny questions around what decentralization does and what incentivizes or disincentivizes decentralization. And it's really hard to quantify. That's one of these central things. Is I'm ultimately a very qualitative person. Numbers are really tough for me. I don't know if anybody believes me on that, but like I like am persistent, but I've struggled through like every math thing I've ever done, like very, very hard. I just didn't give up, and it never like comes naturally to me. But that's why I always try and I'm like, okay, I have these qualitative beliefs, but I want to test them. I want to use numbers, and I've never seen anybody ever put out any sort of quantified decentralization anything for Bitcoin. It's always just like hand wave conjecture. This seems better, and I don't like that. But that's kind of where we are. Does anybody have anything that they're like, oh no, you're just missing out on like this real, true decentralization metric? Yeah, I mean, I've looked at some of them, and they all end up being things like node counts and things like that. And it's just the one that I liked the most that I've seen was who does anybody remember James D'Angelo? I guess I'm like dating myself here. He was like very active for a while, and then he kind of faded out of relevancy. But he always used to say that like consensus, the thing that you have to count is noses, not nodes. It's really just the unique number of people, and like that is a metric that is quantifiable, but it's not one that's observable. But it's still a quantifiable metric, which I think is important. Even if you can't observe it, it's still something you could say like how many people are involved in this decision making. So that's still a good thing, because if you can like one of the things that I did in Bitcoin Miami was I did a poll and I said who in this audience runs a node, and like 100 people raised their hands. Now I know that at least 100 unique people run a node, and I didn't know that before, right? Like maybe they lied, but like how many people here run a node? Okay, now I know that there's like 20 or people or something like that who run a node, and that's a real metric that matters, right? Like I know that the network is not just all like a couple mining pools, which otherwise I wouldn't know that. So tough to quantify. Maybe we can have an
Lightning kind of helps with that a little bit, because it's not perfect, but there's a cost to running a node, and that you have to lock up funds.
They're just saying that Lightning helps with this a little bit because there's a bit of a cost to running a node, whereas like a normal Bitcoin node, you can just spin them up as much as you want, especially if they're pruned. It doesn't even take that much storage. But for Lightning, you have to lock up funds, and that has some Sybil resistance. Obviously, like you can, one person can run multiple ones, but it kind of narrows it down a little bit, which I think
is kind of like a proof of stake system.
I legitimately believe that is a proof of stake system.
Yeah, fair. I'm just busting your chops here. Yeah, I think that's a good point. Like you have different behaviors. It is Sybil attackable insofar as like somebody could pretend to be like, they could say, I'm going to advertise 2 routes with like kind of competitive things, but they're both going to be good. And then you're creating the, perspective that Lightning looks like there's competition, looks like it's an efficient market, but really you're running, 2 of the big routing things. So you could have some Sybil attacks and that kind of stuff.
It's not Sybil proof, but it's somewhat Sybil resistant.
Yeah.
It has like some protections. But Anyway, like it helps. It's like better metrics than we had for nodes, I think, because and then you can compare that against, and then you can also use proxies like Twitter, as terrible as it is, like, again, not civil proof at all, but like, the unique engagements and there's histories associated with it.
Yeah, well, I think even if you're being Sybil attacked, that person who's on the other end of your channels has locked up a significant amount of collateral to be in this thing with you. And like that is itself an investment that's like a tangible, investment in that network. So I agree with you on that 100%. So yeah, there's a lot of like mining pools are also problematic is like another decentralization topic, and just mining in general. I think the trend's been really positive in terms of like getting China less in the mix. That's been really a good thing, even though there's now like more American companies. Like there's also a lot of like little individuals who are parts of those things. So I think that's been a really positive trend. Did you want to say something?
No.
Okay. Anybody else want to chime in on decentralization at all? Okay. So I think this is last. Yeah, this is last. There's privacy, and who's here likes constitutional law? Okay, so we all know as constitutional law scholars that like there's nothing in the Constitution that like says you have the right to privacy. So it's what's called like a non-enumerated right. That doesn't mean you don't have it. The way that the Constitution works, and like I'm a God bless America patriot and everything. So like the Constitution is the perfect document for everything and never needs any fixes or something like that. But the way the Constitution works is it actually doesn't give you any rights. It protects you from the government infringing on rights that you already have. So just because something's not in the Constitution doesn't mean that you don't still have the right. It just means that maybe the Constitution is insufficient for for the purposes of defending rights that you already have. And so that's a useful framing. And sometimes there are rights that the Constitution spells out things explicitly, and there's no way of achieving that right unless you have some other right. It's kind of an implied right. And privacy is one of these things where like, who knows, like they're like Fourth Amendment and Fifth Amendment rights. Okay, no unconstitutional search and seizure, and you can't like provide evidence, like be compelled to provide evidence against yourself. Those are really important things. Those are kind of privacy related things. If you don't have privacy, what's to stop the government from like, reading all of your mail or something like that, or, breaking into your computer, breaking into your house? You have some right to privacy. And if you're not bothering anybody, you have a right to be, kind of left alone. These are things that are not enumerated rights that are really important. The bad side of this is that privacy is just sort of like physically like not possible. Like, Newton's law, like every action, equal and opposite reaction. Like if you do something, like it causes some butterfly effect in the universe, and maybe somebody can learn something about what you did. Now we have a lot of things that like get in the middle of that, which is like, well, you writing a text message in Signal, like unless somebody's like looking over your shoulder, it's been encrypted, and probably like that information doesn't really get out in the world through some butterfly effect thing. But you think about it, you're like, well, what if you sent it to a friend and the friend just tells somebody else? Like these things do escape, and it's really difficult to actually create this thing called privacy. Probably like ultimately impossible. That's where a really important concept comes in, which is time. Privacy is always something around time, which is like, are you private for long enough to accomplish whatever your goal is? So if you think about like military stealth technology, right? That's about privacy. But if you're a stealth bomber, your goal is to be stealth long enough to drop the bomb and get out. The bomb obviously exploded. They know there was a plane. And again, these are probably sensitive metaphors now, but the plane was there. They know that there was a plane there. They know probably who the plane was from. They can probably figure out after the fact, like line of sight, maybe people can see, but a lot of these things are just being private for long enough to accomplish whatever you want. So an example of this would be, I want to be private with all of my financial activity until I'm dead and my children are dead. And then after that, I probably don't care. So when we talk about things like encryption, there's always a notion of like, well, how crackable is this encryption? Will the computers in 1,000 years be able to crack it? You probably don't care at that point. Like what secrets last that long? Even for like the government, like the top secret stuff, like it's got like, what is it, like 70 years or something? And then they declassify a lot of things. Like you always kind of have some budget in mind with how private you want to be. And in Bitcoin, we all know that privacy kind of sucks. And the reason why I'm giving this primer is that like, I think the way that Bitcoin is architected, like eventually the truth kind of comes out of like who has what, and there's some sort of gated action that you'll take where you're going to lose some amount of privacy. The question is, are you able to hide other parts of your path to getting there? And how long can you keep those things private from people who might want to either censor you or might cause some issue for you in general? And that framework of privacy, I think, is useful to have in mind because I think it's very easy to get yourself in the loop of going for like perfect, inscrutable privacy when those things might just be permanently out of reach. And that shouldn't stop us from like taking opportunities that like dramatically improve how much information you're getting rid of in the meantime. And so that's a thing like CoinJoin, for example, where is CoinJoin information theoretically secure? No, it's not. But like, is it a benefit? Yeah, maybe. There ends up being problems with things like CoinJoin as a technology because like one, you can be attacked through it, and two, like the information becomes public like pretty quickly maybe, and you work with people who like also maybe have something to hide. So there's some issues around that, but generally privacy is kind of this important thing for Bitcoin because like you don't want to self-censor yourself, and you don't want your personal decisions to lead to some negative consequence in the future. So everybody's like, oh, I've got nothing to hide, so what am I worried about? But like, in 10 years, it could be anybody who tweeted negatively about some political leader is now getting rounded up and shot. And that's something that like, this sounds hypothetical, but like this is happening right now in Ukraine. Like, and I don't want to get too political, but like, Putin's forces are going after people who are opposed to Russia, who are like local political leaders. And what was their, crime? It was maybe like they tweeted something like, years ago, and now it's surfacing up. And so when you think about these privacy budgets around a CoinJoin, like if you're using it to do something bad, you really have to be certain that the privacy budget is going to be long enough that you don't face a consequence from that action later. And this isn't even for doing things that are like bad. This could be doing things that are good, but later become bad in the eyes of somebody who's even worse. So I think sometimes these things get wrapped up in like a more like yeah, sure, yeah, that's a great example. I mean that's one where it's very divisive, right? Like a lot of people wanted to support them, and I think a lot of people who sent that money in support did not properly assess their own personal risk, because I guarantee every one of those transactions has put anybody who did that like on a pretty big watch list of some kind. So like those are things that like you have to really think about this stuff actively. And if nobody has privacy, like I also think that Bitcoin just kind of fails. And so in a similar vein to self-custody or decentralization, like it's kind of a fundamental property that if we can't figure out some better stuff for it, we're in deep shit. So any questions about privacy? All right. So what's smart about smart contracts? It turns out that for any one of these things that we just described, smart contracts, when people think about things as a pillar, they think about first you build the foundation, and then you build, I guess, the pillars, and then you build the roof, and then you put the furniture inside. And that's kind of a little bit off in my view, because I think it turns out that you need to actually start with the roof. You need to start with the things that are on top, and then if it's an archway, those things actually provide the space underneath for the things that you care about and provide the foundation from the top. And I think there are good examples of this in, when people talk about in Bitcoin, sometimes they'll say things like, we don't even know how to build a decentralized network yet, so we can't even think about having smart contracts like Ethereum has. I think there's a lot of validity to saying something like that. But then you look empirically, and maybe it's anecdotal because we live in a world of only anecdotes, but you look empirically at like, well, how is the development of privacy progressing in Bitcoin versus in like an Ethereum ecosystem? You go, Ethereum has things like Tornado Cash, which I know they had some recent public thing of like they have an OFAC list, but that's like a UX thing. That's not really a part of the protocol. There's been a lot of development of like zero knowledge rollups, which maybe have some interesting privacy properties. In terms of sort of self-custody, there's things like Gnosis Safe that are like, maybe more institutionally focused, but like really cool for managing digital assets in a way that has more rules around it. And you look at scalability, and then there's much more ability to do these like zero knowledge rollups, optimistic rollups, things that are kind of like drive chains that people talk about as maybe this is like a big deal. And Bitcoin doesn't have the innate ability, today to do a lot of these things because we don't have the primitives for smart contracting. And it's not that I want I know this is like maybe like a DeFi adjacent audience because we do a lot of things in like fintech space. I think that stuff is important too. I didn't put that as one of the pillars of like Bitcoin has to do this. Like Bitcoin is already doing a lot. And if we didn't have any DeFi as a part of Bitcoin, I think it would be okay. For Ethereum, a lot of, people do a lot of fun stuff. They're DeFi, they're degens, they're doing NFTs. But the thing that I think about is that, maybe I have some slides that are, this one's probably better to look at. The thing that I think about is that I really care about things that are like these end states that are getting built. And people have said for a long time, Bitcoin will just like copy the things that like succeed in the wilderness. And I don't think we really have like the competency to do that. And I'm a free markets person. And so what I kind of think is that like, we should maybe just have like more ability to produce a variety of things inside of Bitcoin. And we don't necessarily need to be as extreme as Ethereum on that front, but the more experimentation that we build, the more build into Bitcoin, the more likely that we're going to produce from that base the things that end up reinforcing the properties of the system that we want. Better self-custody tools, better privacy tools, better scalability tools, and better decentralization tools. And for each one of those things, like we can go into a laundry list of examples of like, we saw vaults, that's really great. NFTs, maybe not super important for any of those categories, but there's things like payment pools, which are both a privacy and a scalability technology. And that's something that only really happens if you have a little bit more smart contracting stuff going on. And not all of this is even stuff that requires consensus changes to happen. Like we saw Sapio is able to enforce covenants just among a federation. Just that alone, just the ability to reason about things as a stateful smart contract in Bitcoin is something that brings us a huge step forward in our thinking. But people get a little bit upset. They say Bitcoin already has smart contracts. We don't need things that look like what you could do in these other ecosystems. But I think it's actually very important that we have that because I don't have any confidence that we're going to produce the things that reinforce our pillars otherwise. That's sort of my perspective. One of the metaphors that I use, maybe somewhat often, is that Ethereum as a community is a lot like kind of like China, and Bitcoin is a little bit more like America. And who here has like spent time in China? For the average person, where is there like more capitalism? Like in your like lived life as an entrepreneur? You think here? Okay, how much would it cost to open like an ice cream shop in America?
Depends what state.
Yeah, fair enough. Different states, different rules and stuff. But in most of the United States, there's like a tremendous regime of regulation and liability and all these other things, where at the small scale, like you hear sort of the horror stories of people who spend like hundreds of thousands of dollars trying to open a restaurant and then go bankrupt. And if you spend time like in China, like at the small scale, like there's a shop that somebody is running on like every corner with like no health regulations or no workplace regulations, and you're like, this is kind of scary, but like it seems to be working. And then if you go and talk to some of those people, and I've spent a decent amount of time there, nowhere near as much time as Buck, but like I spent like a month or two there. You talk to people and you're like, hey, what's going on with your little like corner electronics store? And then the 22-year-old shopkeep girl is like, oh well, like I'm running the shop right now because like I got a younger brother. I'm sending my younger brother through mechanical engineering school. When he goes through mechanical engineering school, we're going to open up a factory for injection molding, and then we're going to vertically integrate it. And I'm like, I've never met anyone in America who is doing entrepreneurship like in that kind of way at that scale. This is like you go into a random stall and every story is kind of like that. And Ethereum like really looks like that. Like if you go and talk to like somebody who's building on Bitcoin, like I'm somebody building on Bitcoin, you're like, hey, what are you doing? And I'm like, I'm trying to convince the Bureau of Core Developers that my proposal is the optimal thing for all of society. And I've been doing this for the last 2 years, and it could be another 2 years from here. But you go into Ethereum, you're like, hey, what are you doing? You're like, I'm reinventing DeFi and I'm doing a whole new roll-up sidechain. We're gonna have this crazy zero knowledge system. And you're like, okay, whatever capitalism is, it's competition. And there's the competitive ecosystem happening in Ethereum, there's just substantially stronger market pressures and selection pressures. And I'm a very big capitalist. I believe that at any given point in time, that looks like a complete disaster, but the momentum that you build with more competitive pressure is actually one of the strongest forces, in society, the universe kind of thing, that's what produced humans, right? We evolved through this mantle of death and destruction, right? And that's what Bitcoiners are oh no, we have to have the most stable society of all time. The most stable society of all time, they always die. Things stagnate, they stay the same. People lose competency in solving hard problems, and then you end up drinking lead water for a couple of generations, and everybody's dumb as bricks at the end of that, and then society collapses. That's the fall of the Roman Empire or something. So it's one of these things where if we lose our ability to innovate, we're kind of screwed. Now, when you get to the large macro scale, that's where Bitcoin is winning. And that's why Bitcoin continues to win in the macro landscape for now, is that once you're doing something and you're doing it well in China, you're kind of screwed. People are going to show up at your door. You're going to get disappeared if you're too outside of the priorities of the state. And in Ethereum, if what you're doing is liked by Vitalik, he is going to make proposals and get them through that benefit your use case. And if you get Vitalik on your wrong side, he's going to find a way to make your application no longer possible, because it's not good for the society of people trying to build good things on Ethereum. And this has happened with gas token, for example, is one of the kind of more famous examples where people owned this token and Vitalik just kind of nuked it from orbit. It was boom, this thing is gone, and it doesn't work anymore. And then in Bitcoin, we kind of have this property where once somebody's doing something, we never want to mess with it, even if it's bad for everybody else. We're hey, look, we get it. You may have used Code Separator once in 2011, and because Code Separator existed once in 2011, we will permanently keep a massive denial of service vulnerability around in Bitcoin. Is that a good thing? I don't know, but that's sort of the norm that we have. And it's more similar to America, where once you're operating a business at scale, the government really tries to stay out of your way. Now, maybe you have some politicians who want to change that, but once you're operating in America and up and running, things are designed to be stable. You're designed to be able to have what's called a reliance interest in our system. And Ethereum does not give you a reliance interest in the system, Bitcoin does. And that's why ultimately when you're thinking about where you might want to deploy and build something in the very long term, Bitcoin looks more attractive. But in the short term, there's way more value creation happening in other ecosystems. And I think, we should probably change that. We shouldn't compromise, but we should, incorporate the parts that are good from what we're doing at the smaller scale in other ecosystems.
I also say it's kind of funny that there's also a lot more rug pulling in China's capitalism. It's just a part of business life. It's yeah, there's a good chance this business is just going to be gone in 2 weeks. But it's working out so far, and so I'm going to keep on using it. But they also don't have a choice.
Yeah, absolutely. That is just kind of that's what real capitalism kind of looks like. And and this is something I always see, is that I always see a lot of people who are hardcore Bitcoiners getting very excited about SEC enforcement actions against Ripple and Ethereum, or and they're always the SEC is gonna get them. I'm why are you cheering a regulator stopping people from participating in a voluntary system? If it's a scam, it will fail in the markets because it's not providing value for people. If it's somebody made a lot of money and it's providing value for a lot of people, I don't have a problem with that. You provide value, you make money. That's how the universe is, set up. And that's something that I think, when I think about the social norms that we want, I think people should sort of skew more towards capitalism and also skew more towards education. And that's the thing that people get, upset about, which I think is right, is that, well, people maybe just aren't educated enough. And I'm not sure that gatekeeping and hand-holding is the way that people become more enlightened. I think people go through the churn and they come out, a learned or unlearned person. And, maybe there's some sort of, if you're really, have an issue with it, don't try and use, the full brunt of the state against somebody. Put out a blog post, write about how the properties of the system that they're claiming they have aren't there. That's how a free market works. It's not something where you get somebody to go beat somebody else up because you disagree with how they're doing something, unless they're doing something that's killing you, then you maybe involve the state authorities because we want to live in a society that's not based on force. Anybody want to jump in?
Fraud is theft.
I think that's fair. There are different types of fraud. So if you have a contract with somebody and you do not honor that contract and you run away with the money, that is theft, I would agree. But if you say, hey, here is a system, here is how let's say it's tokens, here's how the tokens are being distributed. It's a distribution that very much favors me. You can have it, you can buy it if you want, here's the price. We think it's gonna go up in the future. And if this is, don't cut this into, don't audio clip me here. But is that fraud? I mean, a lot of people would say like, yes, these are fraud, they're scammers. But like, if that is fraud, it's like, well, what communication would have to happen for it to stop being fraud? Because I think people are free to buy and sell whatever they want. Maybe if there's a lie baked into that, that's creating a contract and a reliance interest that is then violated. But as long as I think it's like, it's clear information, like I don't think that, a lot of these things that people would call fraud are actually fraud. And I don't know if you have feelings about that in particular. I agree with you, fraud, if it is fraud, it's, a crime. What do you think?
I've said my piece.
Okay. Well, I mean, I'm always open for, good debates. So, yeah, don't do fraud. If you're going to do something wild, at least be honest with what it is. So how are we doing on time in this session? Are we trying to wrap at 11:30 or?
11:21.
I don't know does anybody know what the schedule is? Buck left. All right, well, I'll keep going. Okay, so when we're thinking about covenants, there are a couple different properties that we try and think about, and I'll skim over these now because it gets a little bit too technical. But you're going to hear a lot about covenants in like the coming months, and this is kind of like your starter pack for like what people are talking about. So there's recursive versus non-recursive covenant. Recursive covenant is something that can perpetuate itself indefinitely. So you say, hey, these funds are going to be in a, let's say a discrete log contract that is a recursive one. And you're able to take out maybe some of your earnings, but like perpetually the rest of the funds have to stay in and get rolled cycle to cycle. And it's always under the control of the oracles you originally selected, let's say. That's kind of a recursive covenant. A non-recursive one would be something where it's like, well, we've guaranteed that you're going to have some set of outcomes, but we can guarantee that it terminates. So we know that it's only going to be for 3 months. This thing will be in this discrete log contract thing, and then after that it terminates. And that could have some element of like it looks maybe a little bit recursive, but as long as it terminates, it's kind of not this thing that we're calling recursive covenants. Yeah.
By the housing analogy, is that to say that like the first purchaser can't sell it to someone of a particular demographic, but the next person could, or that they can't sell it for the next 3 months, or both of the above?
Yeah, so that's a good example. In the blog post for this one, I have a bunch of examples for each one that like breaks it down. I can't recall them all off the top of my head, but like absolutely that. A non-recursive covenant would be like, I am selling this house to you. You may not paint it blue for 10 years or something. Okay, it's ruin the neighborhood. And so you can't do that, but then it expires and you sell it to somebody else and like they can paint it whatever color they want. So that's kind of, one of these things. And a recursive one would be like, no matter who owns this house, it may never be blue. Okay, or no more than 3 people may live here, that kind of stuff. And then the next one is like fully enumerated versus open-ended. Oh, are we wrapping at 11:30 or 12? Okay, cool. Is fully enumerated versus open-ended. So an example of like a fully enumerated covenant in this housing context would be like, for all time, only this buck may live at this address. And that would be like, okay, it's fully enumerated. We know this person. Or it would be, for all time, only the set of people currently in this room may live at this address. Something like that. Versus an open-ended one would be, anybody who's 5'11" can go into this house, right? Like, okay, maybe that's the rule, and it's open-ended. We don't know how many. Like, there could be a new person we didn't know about. You could imagine this in a crypto context of like any taproot address. Okay, any taproot address. But a fully enumerated one would be like these 5 taproot addresses, or open-ended could be like any taproot address that's been signed by this other key could be used here. So those are things that are kind of more open-ended versus fully enumerated. It's a slightly different concept than recursive versus non-recursive, because you'd imagine a recursive covenant that says the oracles for this DLC have to be fixed for all time, and you could imagine an open-ended one which said you can rotate the oracles however you want, but you have to have oracles in general. So it's kind of a slight difference, yeah?
Would it be correct to characterize TLUV by design as open-ended versus CTV being fully enumerated?
This is a bit in the weeds because like TLUV is like a very particular opcode proposal, and we won't really have time to go too in depth on what it is, but I would say it's recursive. And in terms of fully enumerated versus open-ended, I would say it is open-ended because even though like you probably can enumerate it in spirit, it's supposed to allow arbitrary transitions with arbitrary amounts. And you could be like, oh, but the amounts are limited to 54 bits. Like, to me, that's sort of the spirit of like the state transitions are open-ended, and you can also like add funds in after the fact stuff as well in some designs. So I think it's more on the end of fully recursive and open-ended, but there's some cases to be made, maybe it's a little bit closer. It's not like fully open-ended maybe in the same way, but it depends on how you particularly use it. So I think these are properties. So one thing that's an important thing is that there are properties of how you use a covenant, and then there are properties of what's the maximum possible thing you could do with a covenant primitive. And those are two different. So when you say TLOV, we're talking about the maximum thing that you could do with TLOV, versus if you said like, well, what about payment pools implemented using TLOV, and then that would be maybe a subset of those properties. If that
I think
makes sense.
when we're evaluating the proposals for how to do these things, like the maximum amount possible is what we really care about, because that's like what exposes the potential dangers to undermine the pillars of Bitcoin, for example, right? Like you want to know what might happen to it, which then could undermine the properties. Because that was one of the early concerns with covenants when they were first proposed like 5+ years ago, was this will allow for essentially KYC coins, for example. And you're like, well, we don't want that, and that would undermine the property, so we avoid that.
Yeah, good observation. So the next topic is client versus consensus validation. So this is pretty simple. Like the NFT that we saw, that was client validation, right? The actual chain wasn't really checking out those properties. We were checking those properties using Sapio. Taro is also client-side validation. So is RGB. So is Counterparty. These things are all client-side validated. Consensus validation was like the vault. Like consensus is forcing that to go through that flow. Any questions on that one? Cool. The next is validation versus computation. An example of this is like, I give you a deck of cards and I say, sort it in order or something like that. And you've got to put it in order. That's a computation. There's also just validation, which is I give you a deck of cards, check that it is already sorted. And certain covenants feel, a validation is a computation, but it's somehow like a less significant computation. And certain covenants are a little bit more on the realm of, I've submitted the thing, please check that the thing is correct with a small amount of work. And there are things that are more like, well, actually the covenant is really like figuring the thing out inside of the loop of consensus. And so something like, you could imagine like adding op run Python would be like a computation thing, whereas like op, check that this list is sorted is, that's more of a validation property. And I think something like TLOV like kind of is more in the realm of computation versus validation, because it's really computing what the new taproot output should be, but you have to also already have that committed in the transaction. But it's a little bit more on the side of like the computation is happening in the script than as just like a validation of something else. Signatures are like validation, for example. The next is dynamic state. And so this is one that's also kind of a critical concept. Like Ethereum is like full of dynamic state, right? You have like databases inside of all your contracts. And then you can also have a contract which like anywhere that you're like locally, you have all the information to validate if this thing is correct or not. An example of dynamic state that's been proposed in a covenant for Bitcoin is drive chains, where there's like some external databases that are being tracked. And when you just look at a drive chain transaction, you need to have some other index of state in order to validate that transaction. And that's actually sort of a fundamental problem in the drive chains specification is like Bitcoin is very careful to avoid dynamic state that lives outside. And so it's kind of like you maybe need to make that dynamic state live inside the contract so that you get back this local validation property. And that's an important one. You can still have things that are like kind of like dynamic state. For example, you could enumerate all of the possibilities of the types of the reachable states of that dynamic state, and then maybe that would be a little bit better. Maybe you can bound the dynamic state. You could say the dynamic state is no more than a kilobyte of space, rather than like it's an unlimited size hash table. So dynamic state is just another thing to think about. Like if you're a programmer, it's like basically like, are you an embedded system or are you running on a general purpose computer in the cloud, or something like that. So the last one is something that you're gonna hear a lot of heat about, and you'll hear people use terms like CISC and RISC, because it's like complex instruction set and reduced instruction set complexity. I forget exactly what RISC stands for. But these are two things where like there's some notion of like, was this opcode designed to work in like a very arbitrary high level context, or was it designed to solve like one specific purpose and do only that thing? And how specific is that thing? I think, and maybe this will be controversial, but like the people who are introducing the RISC and CISC terminology heavily are like completely misusing it. And from my perspective as an advocate for CTV, like they're saying CTV is a complex instruction set, where I believe it's actually a reduced complexity, thing, because it's the way that it works. It does one specific thing that you have to like maybe use inefficiently from the perspective of like number of ops executed, but it turns out that you can do it in a really nice way, and it's cheap to use and cheap for consensus. So it kind of is the reduced complexity thing that you have to use in a more sophisticated way to get the outcome you want, versus a complex instruction set thing, which is sometimes billed as like, well, so people get it backwards, and that's why I'm gonna have trouble explaining it to you until you kind of drill into it. But it's like, oh, well, like let's have more computation happening inside of the opcode. That's a more complicated thing. Like the RISC machines, if you actually look at what they have, like a RISC machine could just be only addition. And addition and maybe jumping are the only two things that are defined on that machine, and then you can run it at like a crazy fast clock speed. And then for like a CISC machine, it would be things like TLOV is kind of a CISC like opcode, because it's like it's manipulating a taproot Merkle tree and tweaking keys. Like, couldn't that be decomposed into like 5 separate opcodes? And it already is like 3 separate opcodes itself. So for the proposal that was made. So that's something with like the general versus specific. Like you always got to think of like, is this something that is like designed for like only one application, or is it general purpose? And then also like, if it is designed for one specific thing, can you use it for other things? Does it happen to end up being general purpose anyways? And how ergonomic is that process? There's way too many things to get into here. We can talk about any of them in the more technical side. But a lot of people, what they don't get is that like we're building a virtual machine here, and you don't just get to run one opcode in your entire program. Like you have actually a series of things that you can compose. And this gets to the point that I made earlier of like, there's how you use the opcode in one instance, and then there's the set of maximally wild things you could do with that opcode. And it turns out that like a lot of these things you can use together in very synergistic ways. So one of the ones that like people commonly don't know is that like everybody who here knows about like any prev out or like BIP 118, so a decent number of people. What a lot of people don't realize, who hear sort of like L2, like the ELTOO, like Decker channels, that kind of stuff. Like people have heard of this, but what a lot of people don't know is that like actually like check template verify and check sig from stack, which is like this like ancient proposal that's like so boring, nobody's gotten over the hump to like implement it in core, because by itself you can't do much with it. Actually, that gives you something that's equivalent to what you can do pretty much with any prev out. And so when you view these things as like, well, what is the reduced instruction set complexity? That positions any prev out as the more complex thing because it can be decomposed into its two constituent opcodes of check template verify and check sig from stack. And maybe those are like two simpler primitives we can build the other primitive out of. And if we want a simpler machine, then we wouldn't, unless there's an optimization reason for it, we wouldn't add the more complicated thing. CISC things get added for optimization purposes. This is why people get confused about CTV in particular, is because it's very efficient. So people think it must be CISC, but it just happens to be very efficient as a RISC opcode. Does that, there's a lot of stuff to talk about, and we can get into detail in any one of them. Yep.
What are those acronyms again?
Check template verify. Oh, complex instruction set.
Computer.
Huh?
Complex instruction set computer. Reduced instruction set.
Okay, gotcha. Yeah, I was mixing it up. Thank you. Yeah, so interestingly enough, there was a period of time where the CPUs that were complex instruction sets were just cleaning up and killing it, and that was what everybody used. And then the RISC architectures started getting really, really, really good. And if I understand correctly how the CPUs are set up today, what ended up happening is you have a RISC system that is embedded inside of a CISC preprocessor. And the CISC preprocessor now translates the code that's running into a RISC code, and then that's what ends up running. And it's sort of this hybrid model where from the user's perspective, who's writing compilers and assemblers, they're writing these complex instruction set things that are very nice to write, nice to compile programs. But then when the computer's actually executing, it has a little compiler inside of it that's translating it into RISC things for the computer to actually run. That's kind of this microcode, infrastructure. And it's pretty cool. It's kind of worked out decently for the companies that did it. But I think we'll probably end up in the long run going towards RISC stuff. We're there with the CISC stuff because Intel made that choice. But I don't remember what breaking news is.
Oh, those are new ones.
Oh, okay, these are all the new ones. So now every day on the mail list, somebody's I've got a new idea, and here's how it should be, and this is the best one of all time, and all the other ones are bad, and we should do this one. So the message that I have around that is when you're approaching these conversations, be an engineer. And even if you're not an engineer, approach this from an engineering discipline point of view. Think about design specificity, right? Is this thing, is there another way this thing could be designed? Or is this approach for the problem it's trying to solve, pretty close to the only way to solve the thing? So, there are lots of examples you can get into, but things like stairs, right? If you're walkway stairs, if you're I'm going to innovate stairs, you should probably not do that. Stairs work pretty well. The design of one stair after, maybe you can talk about accessibility, and that's an important topic, but don't go and make stairs really tall because it'd be more fun. That's it's kind of the right size, of I don't know, 6 inches or something like that, 12 inches. I don't know how big stairs are. But don't innovate there. Design specificity, is it the right design for the task? How much play is there? And there are things that have a lot more play, automobiles. You can design lots of different types of cars, right? You kind of need 4 tires unless you're on a motorcycle. And that brings us to safety. So how dangerous is this thing? So with the automobiles, cars are actually pretty freaking safe. If you think about it, you can travel faster than humans were ever intended to travel, bang into another car or a brick wall and survive. That's pretty cool. You can't do that on a motorcycle. And I know there's some bikers in the crowd, and I don't think that's even controversial. If you get into an accident, you're screwed. You have to really not do that. And so you can think about covenants in this regard as well, is that well, is this design something that encourages a safe usage of it? Or is this something where there's really a lot of foot guns and we're gonna find out later how it's broken in some subtle way because somebody's trying to use it correctly? Is the design conducive to correct use? This is what we talked about earlier with the full enumeration of the contract state is kind of useful because you can know and statically analyze all the things. But for things, in my opinion, like T-Love, it's a little bit harder to guarantee that when you have this open-ended recursive thing that you don't accidentally get into a stuck state. It's a lot more difficult to prove that these things can't reach some invalid state, can't hit some brick wall. Whereas for something like CTV, in Sapio or multi-sigs in Sapio, you can kind of say like, did my program generate a brick wall? Then I probably should not send funds to it. That's a little bit easier to do. And then also this sort of synergy question of like, does A work well with B? Or does A and B cause something really negative to happen is sort of another thing to think about. It's not enough to just say like, my thing is good in and of itself. You've got to think about how it might work with everything else later on down the road. And we've messed this up in a number of occasions in Bitcoin. An example, being some of the stuff around like Taproot, like we didn't keep in mind strongly enough composability. There's a lot of composability baked into Taproot, but there are certain things that, it's more in the weeds technical stuff that we can talk about where it's like, like maybe if we knew that we would be doing something like this, we would have done it differently. An example I'll give just off the dome is like the sorting of the Merkle tree at each interior node. Like if we knew that Tara was going to happen, we might not have done that so that the sparse Merkle tree could be embedded natively within the Taproot tree itself. Like that would be kind of like an innovative thing that would let you do proofs that like certain leaf nodes don't exist, but because it's sorted internally, like I'm pretty sure you can't quite build the same sparse Merkle tree structure inside of Taproot. And we did that to save like 1 over 256 bits or that's a pure number, 1 over 256, of space for a Taproot exposure. And like, that's not, in my opinion, like enough of a space savings to justify like additional protocol complexity. So that's something where, you got to keep in mind like how this thing might work in an ecosystem of things. It's also an example where like things like Tapleaf update verify become a lot more complicated to do because you've got to now not just like, assemble a Merkle tree, but you've also got to sort all the nodes as you build it up, which like makes, if you wanted to write a script that manipulates a Merkle tree, like that's a lot more complicated now. And doing covenants over Taproot is like probably like a very hard problem. And if people get serious about doing this stuff, we might say, oh, why don't we do a Taproot v2 where the Merkle tree is just as what you see is what you get order. And I wouldn't be surprised if that happens at some point. And that's kind of like one of these things where composability ends up being really killer to think about. So I've talked a little bit about what CTV is. Does anybody have any like questions or want to like stop just because it's a little bit of a transition? How's everyone doing? Is anybody just like, fuck this guy, this is like confusing stuff and I'm stuck here because I want to be polite? Okay. So anyways, what is CTV? Well, all it is in terms of design specificity, the ability to commit to a pre-signed transaction in a script. So who here knows what a pre-signed transaction is? Okay, most people. So if you don't, all it is like before you send money to an address, you say, here's the transaction I'm going to do. If I did this transaction, will you or will I, whoever has the keys, sign some future transaction I would like to do before I send the money? So that I'm sure, let's say it's a multi-sig like Lightning, I'm sure I'll be able to at least do that transaction in the future. And maybe for a Lightning channel, it's like a dual funded channel and all you want to, or a single funded, whatever it is, all you want to be sure is you can get your money back. You don't care if it actually becomes a Lightning channel. You just want to know before you send the money in, you can get your money back. Sounds pretty good, right? Who wants to like not get their money back? Okay, anybody? All right. If you did, I'd say see me later. So that's all that CTV is that instead of having to do this interactive dance of like, let's pre-sign this thing before, you can just directly embed without having any sort of process that ability for that transaction to happen is sort of the key concept. And that specific thing, there's not too many ways of doing it. There's like a couple different trade-offs you could make, a couple different design decisions. But if you sit in your bedroom alone for like a year, like I did with no friends, you kind of come up with something that's like CTV no matter what you do. And I'm pretty confident that like if any of you, without looking at the BIP, set off to like try to do the thing just based on that line, ability to commit to a pre-signed transaction in a script, like you wouldn't come up with something compatible because there's like little minute technical decisions, but the thing would probably be roughly equivalent. You might do one or two things differently, but those are pretty small, bike shed type, designs. Whereas something like, Taproot, would you design it the same way? Like, I think there's like a very wide range of like design decisions that went in. And so there are a lot of things that could have made people happy. For example, Schnorr versus BLS. Do you do this as, the Taproot optimization, or do you do it as a separate mast and then Schnorr as something that goes inside of it? Do you keep ECDSA able to be used with Schnorr with the Taproot key, or do you get rid of ECDSA entirely? Do you, there's all, how much upgradability? Do you have an annex? There's all of these things that are like, well, you could go either way on a lot of these decisions, and it's not clear that this is, most design. It doesn't mean it's bad. It just means it's not the most design specific thing. There's a lot of decision making that went into designing this thing for that purpose. And it means that you have to review more of what those design decisions were. Whereas for something like CTV, you still have to review the design decisions, but as long as you agree on what the goal was, like most of those decisions are already made for you, is kind of the point of design specificity for CTV. In terms of safety, it's just the ability to commit to a pre-signed transaction in the script. So anything that could be done with a pre-signed transaction, CTV is just changing that to not require the pre-signing anymore. But in terms of your ability to construct things, if you couldn't previously do it with somebody who would pre-sign transactions and then permanently die and never speak to you ever again, then you can't do it with CTV either. So other types of covenant have the property that it's somebody who will sign for you and then they continue to be alive. CTV is the kind where it's like the person goes away forever. And so it's a very limited model of like what the new thing is being added. And there's no sort of like, weird assumptions compared to what's possible today. It's pretty similar to what you can already do with Bitcoin. And what people actually do already do. Like people like open Lightning channels and they do it interactively. And you do that because you're worried that the person might die after you open it or might refuse to sign messages. And CTV would enable like a non-interactive version of Lightning where you don't have to go back and forth. You can just open it up. So that's sort of where safety-wise, it's kind of similar to what you can do today, but a little bit better. And then complementary, like we talked about earlier, like you could do stuff with CAT, you could do stuff with check-sig from stack, something called sponsors. So it is kind of designed to integrate with an ecosystem of these things. And there are a lot of nice properties where like in and of itself, it might not be, well, I think it's a star player, but like in any of these things, it's not really like the star player of like what that thing is adding. So if you just add like opcat, you're gonna get actually like a ton of stuff, and you'll get nice stuff with CTV too, but it's like not like an incredibly huge scope change compared to what just opcat would do. If you add check-sig from stack, you get like closer to having something that's an exact match of any prev out, but you don't get like some wild new thing, whereas cat plus check-sig from stack, you actually get like full-blown recursive open-ended covenants. And so CTV plus pretty much anything else by itself is like a pretty neutral ingredient. It's like it's a small amount of functionality more, unless that thing itself, and this is kind of a theorem, it's not like proven, but it's like, unless the thing that you're adding is really adding the functionality itself, CTV isn't going to like accidentally really introduce this functionality just by itself. It's kind of a little bit too limited for that. So it's kind of nice because anything that you add that's trying to do something cool, CTV will augment that. But anything you add that's not trying to do something cool, it's probably not going to make that go too wild. So it's kind of designed to be a little bit fail-safe in that regard. Yeah.
Something else with the complementary. It's also how it's complementary with other aspects of the scripting system, but also with other protocols, right? So one of the things that was a nice selling point for Taproot for a lot of people was that it could, like how you could improve Lightning with it, right? And do stuff with the Schnorr, with music and all that. And I think similarly from what I've been learning with CTV is the way that it can improve DLC protocol as well, or Lightning through channel factories, which is also, I think, like if you have these good building blocks, you can not just do the like main kind of stated purpose for it, but you can also build other things or improve other protocols, which is nice.
Absolutely. Like I would say we just keep on finding out like, and this can be bad, but like we keep on finding out improvements to things people are already doing. And that's a pretty good sign for, what this thing is doing. And like what for me gives me a lot of confidence is we keep on finding improvements, and then those improvements don't lead to, oh, but if only CTV did this in this mildly different way, it would be so much better. It's like, like maybe if you had something substantially more complicated and more sophisticated with much more capabilities in of itself, you could get something better. But for the shape of that design specificity goal, like there's nothing that you would change. And so that sort of to me is kind of miraculous of like, CTV comes out and then you just keep on finding like, oh, here's an improvement for Lightning, here's an improvement for DLCs. And none of them are like necessarily the key enabling thing, but it just makes them a lot nicer. So, I mean, for DLCs, you might make the argument it's key enabling because it's like 300 times faster, but that's open for interpretation. So we've got a little bit of time left, like about 10 minutes. So I think we can cut through a little bit of the content here and we'll kind of jump a little bit faster. So now it's just sort of like, what is Sapio? Hopefully this is kind of like culminating the arc of the presentation is like, Sapio is just a compiler that helps you write covenant contracts. And today it focuses primarily on covenants you'd enforce via multisig or via check template verify. And it turns out that there's a rich theoretical framework for these things, which we'll talk about later on this afternoon, that sort of actually fits any arbitrary covenant. And Sapio is there's physical, like literal Sapio, the thing you can check out from the repo, and then there's like the, is anybody here like ever like, studied religion and knows like if I say like Amal Kitab, does anybody know what that means? It's like the book in the sky of like, there's like some perfect record of like every biblical text, and the ones that we have as humans are like kind of bad, but like there's some perfect, like there's some sort of Amal Kitab of like, of Sapio, which is like but like, Sapio is like trying to be that thing. It's not perfect, but you can think about it. It's like, is this a calculus of covenants? Like, is this a thing that we can apply for any covenant we might think about? And the answer is kind of yes. And there's a nice corollary to that, which is that if you come up with a covenant, you should damn well try your hardest to make it work in Sapio. Because if you can't demonstrate your covenant working and fulfilling the properties that would be required for it to be successful in Sapio, it probably implies some element of your covenant system is not really fully sound, because you should be able to integrate it into this, calculus of covenants that Sapio defines. And if you can't, and the abstract Sapio might be hard to do, literally, but if you can't do that, and that's not, and that you're like, oh, I'm proposing this opcode, but I'm not going to write all the tooling to integrate it into Sapio. You're kind of saying that like maybe this thing is not a fully fleshed out idea, and Sapio serves as kind of a cool piece of infrastructure in that regard. Like, in Miniscript is a part of this as well, but like if you come with a covenant and you can show the how adding the instruction to Sapio delivers new functionality safely and answers a couple questions of like what tooling and infrastructure you need, now we actually know that this is a covenant people are going to be able to build stuff based on. But if you can't do that, it's not really clear that the thing is like buildable, if that makes sense. It's kind of like a claim, and that's a very strong claim. I would invite people to like really strongly challenge that claim and be like, here's an example where this isn't the case. But I think for a wide scope of covenants, it's kind of the case that if you can't build it in Sapio, and this isn't like an ego thing, like I'm like, you got to put it in my thing. I'm just like, I think there's a formal model for this thing. I'm working on developing it. And if you can't fit the formal model, then like maybe what you're doing, is somehow broken in a way that, we'll find out later, because this model seems to be like a good one. We'll talk about the model later. Does anybody have questions on that? Does anybody have? Okay, so we're good. All right, so this stuff is kind of boring. We talked a little bit about it last night. Like, is there a roadmap for this stuff? I published like 5 months ago or something like that. Like, hey, here's what a roadmap might look like if you wanted covenants in 2022. And I published some stuff saying, like, if you don't want this, you should probably like, make some noise now. And kind of then, more and more people are like, hey, we want this thing. And there's a lot of, both like just like, quiet, working in the background developers, as well as people who are like more influential, crypto Twitterati, plus people who are protocol developers, organizations, mining pools who are like, actually this CTV thing seems to be like a good technical direction. We would support a reasonable activation of it, whatever that looks like. And so I don't really know what a reasonable activation looks like. So recently I put out a blog post that was like, well, here's one. Is this reasonable? And there's been a lot of feedback on that. We can get into whether or not that's reasonable. I definitely want to hear feedback on that. Like, I'm trying to define a rigorous framework for like the decision making that anybody could use this playbook in the future. And a lot of people don't like the idea of a playbook. They're like, oh no, this should always be an undefined process. I think undefined processes lead to undefined results. So for me, I'm like, let's have a process. Let's check over things. Let's do this carefully. And also, like, we got to put something out at some point. I've gotten a lot of feedback on it. We can talk about ways that I can maybe be better. And I want to integrate that. I have if you're really worried and losing sleep, I have a plan to kind of follow up on this in a way, I think, based on feedback I've been getting, that like would address a lot of the concerns people have with having a soft fork that starts signaling like in a week or two. Fun fact of trivia that I have for people, if people like Bitcoin trivia. When was the Taproot client that could activate Taproot launched relative to when signaling for Taproot began? Does anybody have an idea? Like, was it like months before Taproot signaling began? Does anybody have any guesses? Was it like, a week before? Any guesses? I don't know if this is the right venue for trivia, but it was after. Like, signaling began on April 24th, and then the client was released April 29th. So there's sort of like this, like, a lot of these things are unintuitive of how consensus works. It's actually very safe that it was done this way, and I can explain why that was a safe decision. But a lot of people, I think, see some of these things, they're like, oh, this timeline is like so aggressive. You're saying that we should have CTV on like next week. It's like, well, no, it still has to get signaled for, and that's a process that takes time. It's just you release the parameter and the clients, and you have an appropriate amount of time to figure out if the network's going to activate it. But at some point, you have to put code out there. But I think we'll figure something out that makes more people happy and addresses their concerns. But I'm worried about the epistemic issues of like, do we actually know how things activate? Do we have a process that one can follow, or is it just anytime somebody does something, people get angry for like a new set of reasons compared to what was done last time? So wrapping up, and then there's over lunch, I think we can get a little bit more hands-on interactive is probably a good way to do it. What I would encourage everyone to do is just be more of like your own Randian protagonist of a developer or like thinker, and like ignore everybody else. Fuck them. Like, what is the thing that you want? Like, if you're like, I wish I had this DeFi thing from Ethereum in Bitcoin, like, it's not that you should force that will onto other people, but you should acknowledge that that's what you actually want. Who here knows what an abelian, I think, paradox is? Have people heard that? Abeline paradox? That's something where you've got a group of people sitting around the table eating sushi because they think everybody else wants sushi, when everybody wants just a fucking slice of pizza, and everybody's like, oh, well, like, I don't want to be the uncultured person, and everybody's thinking to themselves, like, I'd really rather have a slice of pizza right now. Sometimes those things can happen because people don't actually acknowledge what their own preferences are, and when you do that, you end up in a somewhat inefficient system because everybody's doing something in service of this mysterious other. And that's something that I think comes up in development a lot is people will be like, oh, like, you haven't, asked these other people, or what about this hypothetical person? It's like, whatever I want to know is always just, what do you want? Because I don't want to know what you think other people might want, because that's probably wrong. I can ask them, or they can speak up for themselves. It's like, what do you want? And when you're trying to think about like how you should advocate for things in Bitcoin, like, we are all Bitcoin. And so you should, like, if everybody in Bitcoin suddenly changed, hearts and was like, we want the EVM, like, that's probably what would happen, right? So you got to recognize what it is that you want. You have to recognize also like hard rules, like don't steal other people's money, don't commit fraud, things like that. Those are important, like system-wide, invariants maybe. But within that realm, like, recognize what you want, figure out if you can do it later, but at least know, where you're trying to go. Honor the pillars, know that those are things that you want. Don't say, we actually don't want all users, we don't want scalability because we're rationalizing that we don't know how to do it. No, like, keep your eye on the prize, recognize what it is that you want. And if you disagree with those things, recognize those and advocate for it. But don't kind of, just assume that you've got to follow the will of other people. That's how you get like a bad outcome.
To press on this model a little bit, or challenge the model a little bit, how, like, it makes more sense in the framing of something positive or active that you want, right? But what if the thing that you want is ossification, for example, right? It's, we see this a lot in politics where there's the quote, right? Like, standing athwart history, yelling stop, right? But things are still always moving forward. You actually can't ever do that. And so I think, like, one of the issues that people have sometimes in the way that a lot of these things are discussed is, well, I don't want these things to move forward. How you can't, like, do it yourself to do nothing and to like have things stop. So how would you think about that in that framework? Because like an argument like that is as valid as wanting something new in a sense, right? Like that is a feature that you're advocating for.
Yeah, I don't know if I have like a full formed framework around that, but what I would say is that like stopping isn't a legitimate thing to want, and it's maybe like a weird statement, but what you want ultimately is to maybe maintain a status quo, which is different than stopping. And an example of this is that like security vulnerabilities are found. Like that's sort of a thing that happens and will always happen. And if you want to maintain the status quo, you need to have developers who understand the system well enough. And that's something that's always a renewal process. Like you need to, like, you can't just say, oh, we're going to ossify and no one's going to understand the system, because you've actually created a change. And so I think that the homeostasis of any system is like stopping is death, right? Like that's sort of like for like if you are actually stopped, like you're dead in some way. So I think that that's kind of like whatever you're doing, even if it's a stopping goal, like ossification, you need to define it through some set of actions of like, maybe we should be having more, security audits. Maybe if we want to ossify, we should be working on formally verifying the protocol. Like those are positive goals that you can advocate for reasonably. But if you just define yourself in terms of like anti-progress, I think you get into issues where you actually don't maintain homeostasis.
I guess also like in the political framing, we have a problem now where if you say like, well, let's just stop and not have stuff and keep the government away, but then fewer and fewer people actually understand how the Constitution works, how the Bill of Rights works, how like we need to like renew the politicians that support this. You have people that don't understand that are like kind of advocating for your position, but not doing a good job. And the other side that like has no viable defense, and then our rights can be trampled upon.
Yeah. I mean, this is definitely like probably like the least defensible slide in this whole presentation, but it's just sort of like an encouragement for people to like, whether or not you act on it, let's just like recognize what it is that you want. Because I think sometimes people feel like, it's not allowed for them to like say that they like NFTs, for example, and I try to always, some people call it like, what's it like, listening to your goblin or something like that. Like, I don't know. It's like, if you have some desire, like, and I think this is like generally like a capitalism thing, is that like if the market has demand for something like that you don't get, you just might not be like wise enough to understand it for some reason. And maybe sometimes you can always beat the market, but can you beat the market forever? It's kind of a different question. And honor your own market, be a consumer, that kind of stuff. So I don't know if anybody really strongly disagrees with that. It's fine. It's kind of weird libertarian stuff, but. Yeah, talk about it over lunch, I guess. Let's see. So we're a little bit over. I'll just do like 1 or 2 minutes of like stuff, and then we'll break. And I think that's a good fodder for lunch conversation. What I'd say is that like when we talked about this capitalism thing earlier on, and we're like, oh, we should see all this capitalism. Like, where should that happen? Like, is that like, should we have like DeFi? Should we have NFTs? Like, and I think one thing I would push on is that like one of the like weakest places right now in Bitcoin is self-custody. Like privacy is obviously really weak. We don't really know exactly how to fix that. Scalability, we don't really have solutions for how to fix that. We have some ideas of things that maybe work. We've got Lightning, which is helping with that for like, growing the pie of use cases. We have maybe, payment pools or something helps. And then decentralization is kind of this ongoing battle. There may be some out there things we could do, but like vaults is kind of like theoretically a solved problem. And like custody is kind of like there's not any like real obstacle to doing this, but one of the obstacles for people doing it in Bitcoin is like just like the core technologies available to build things that are meaningfully better. Like if you could do a single EVM contract and you could add like something like, I don't know, like a Gnosis safe to Bitcoin, that would be huge. Like you would solve like tons and tons of really complicated custodial issues. And I'm not saying that that's what we should do, but what I'm saying is that like maybe we're starting to see a little bit of a vault revolution. There's a lot of experimentation, a lot of people trying to meet different corners of market demand. And I would encourage everybody to think about this. And this is sort of like, topical for like Unchained and NIDIG as well, is that like maybe this is an area where we can instigate a lot of R&D and have a lot more like custodial types of product, because it's never going to be one size fits all. It's never going to be, oh yes, like this is exactly what everybody wants. There's inheritance things, there's weird wills and trusts, and there's different security setups people want, different access patterns. And I think that there's just a lot of play here, and play is sort of leads to that, experimentation good. The kind of closing point is thinking about how can you add value into that as well. You guys are a company, you're trying to like make money off of this in some way, shape or form, as well as, help people, I hope. But when I think about adding value, I think about you're not extracting value. Somebody is more profitable, over the long run because they are using your thing. Your customers are more successful. People who aren't your customers, they're not going to make it. And what are things that can happen that in sort of the vault layer where users aren't extracted from, aren't in terms of their privacy, their self-custody, but they're aided when they have maybe an emergency? And are those areas where you can add value and maybe like also charge money for that, and people are still coming out ahead on that because they don't have to use you if they don't want to. It's kind of one of these things where you can build with the myriad of technologies becoming available, like light years better custody solutions for people. And there's like not enough R&D going on, for these things. And there's a lot of like low-hanging fruit to pick up that will be like 90% improvements over what people are doing, or even more. And I would just encourage more people to like play around with that, but also think about like, what's the open source version with no providers? And then where can a provider do something based on that makes the system like more reliable or better, or fixes some edge corner case, but doesn't inject itself into the hot path of like what you have to do every day. So that is all on this presentation. I know everyone's hungry, so I will let you all, do some lunch. And if you have questions, you know where to find me. We'll get more technical after lunch.